Okay, good evening, everyone. Let us wait for 2 more minutes and we'll make a review. Yes, good evening, good evening. Thank you. Sure, I will inform about volume 2 also, the management. Okay. Apart from volume 1, I'll inform them to provide volume 2 also. Okay. Okay. First, let us make a review what we learned yesterday. Yesterday, we have discussed a few properties. After that, we defined some of the standard signal spectrum to start with. First, we consider decaying exponential. What is our standard spectrum, sir? 1 by A plus. Then it is increasing exponential 1 by A minus. Impulse gives us constant. Constant in the time domain becomes impulse in frequency domain. Then we observed about the two-sided exponential e power minus a mod t. The respective spectrum becomes 2a by a square plus. Here we stated if the signal is real and even respective spectrum is also real and. Then we considered signum function, real and odd function. Spectrum is imaginary and odd, 2 by j omega. Spectrum is imaginary. Of course, then we considered rectangular pulse. What is the standard form, sir? AT SA omega t by 2, or it can be written in sync form also. Opposite way under duality, what we have learned? Sin AT by pi t. Sin AT by pi t means considering that as a rectangle from minus A to A. Considering that as a rectangle from minus A to. Even we have defined step function Fourier transform also. 1 by j omega plus pi into del. Correct or not? Then we discussed cos function Fourier transform. What is cos function spectrum, sir? Pi into del of omega minus omega naught plus del of omega plus. These are some of the standard signal spectrums which we considered in our yesterday's discussion. What are the properties we studied? Time scaling property. X of alpha t means 1 by mod alpha x of omega by alpha. Then the time reversal property, x of minus t means x of minus omega. Because of time reversal property, which spectrum is changing, sir? Only phase spectrum changes. Only phase spectrum changes. Then we observe the time shifting property. What is time shifting, sir? X of t minus t naught means e power minus j omega t naught times x of omega. Then we consider frequency shifting. If you want to shift in frequency domain, in the time domain, the signal is multiplied by a complex sinusoid. In the time domain, the signal is multiplied by. The last observation which we have made is on modulation property only. Frequency shifting also called as modulation or not. There we stated that any signal multiplied by cos, sine or complex sinusoid is indication of applying which property? Any signal multiplied by cos, sine or complex sinusoid is indication of applying frequency shifting property. Till here we discussed. Some of the examples we studied yesterday. Let us see some more models today on modulation or frequency shifting. Let us see some more models on frequency shifting or modulation property. What are the standard statements we have made, sir? Whenever the signal is real signal, what is the respective symmetry? Conjugate symmetry. Signal is real and even means spectrum is also real and even. Signal real and even means spectrum is real and even. Signal is real and odd. See the cursor. In the case of signal pulse, signal is real and odd means what is the spectrum nature we mentioned? Imaginary and odd function of frequency or not? Imaginary and odd function of. Let us discuss few more models on modulation. Okay. Just a minute. Try this model. Fourier transform of a signal x of t is given as a 2 rect of 0.25 f. Fourier transform of a signal x of t is given as 2 rect of 0. Then we want what is Fourier transform of xt cos 2 pi t. Signal multiplied by cos function means application of which property? Signal multiplied by cos sine or e power j theta form complex sinusoid means application of which property? Frequency shifting or modulation. xt e power j 2 pi fct. Now we are dealing in f symbol. xt e power j 2 pi fct means x of f minus fc. Frequency shifting or modulation. Come on, make it try. X of f is given as what for us? 2 rect of 0.25 f. 0.25 f means internally f by 4 or not? 0.25 f means f by. So where our reference rectangular spectrum covers that? Reference rectangle spectrum covers from -2 to 2, -2 to 2 with amplitude. Everyone use the property and tell me the answer. Let us name yt equals to xt into cos 2 pi t. Let us name that as y of t, sir. xt cos 2 pi t Fourier transform we want. Decide which is the correct option there. Very simple problem. Very simple example. xt into e power j 2 pi t plus e power minus j 2 pi t by 2. Expand cos components are xt into e power j 2 pi t plus e power minus j 2 pi t by. According to our property notation, see the cursor. xt e power j 2 pi fct means what is fc number for the first exponential, sir? +1. Second exponential, what is fc number? -1 or not? First time it is +1, next time -1. +1 and -1. Okay. So when you apply the property here, y of f equals to xt e power j 2 pi fct means what is the answer? X of f minus. So it is x of f minus 1 plus x of f plus 1 divided by 2. First time fc number +1, sir. Next time fc number. What is the meaning of half into x of f minus 1? This rectangular spectrum right shifted by 1 unit. This rectangular spectrum right shifted by 1 unit such that it covers from -1 to 3. 1 by 2 is extra. 1 by 2 into 2 becomes 1 or not? Similarly, what is half into x of f plus 1? Same rectangular spectrum left shifted by 1 unit. Same rectangular spectrum left shifted by, so it covers from -3 to 1. Add them, sir. If you do addition of these two rectangular spectrum, that will look like which option for us? Half into x of f minus 1 one term, half into x of f plus 1 is other term. After doing addition of the spectrums, it will look like second option or not? Funny model. Very simple. Good. Most of you answered. Signal multiplied by cos or sine or complex sinusoid means our immediate thought is application of frequency shifting or modulation. Frequency shifting or modulation property. Rather than omega symbol, now it is given in f symbol. It is given as 0.25. Internally, we can write that as f by 4. Rect f by 4 is a even symmetrical spectrum, -2 to 2 range. It covers in frequency domain, -2 to 2 range. Okay. Let us think about this model. A signal xt with a bandwidth b is put onto a carrier cos omega ct. Omega c is very much greater than b. Generally, omega c carrier frequency megahertz. Of course, I should use the word radian because it is in omega domain. Okay. Okay. Megahertz, kilohertz for your understanding, easy understanding. The modulated signal xt cos omega ct is then applied to the system shown in figure. This is the system. Don't feel this is summing point, sir. It is a multiplier. It is a multiplier. Later on, it is passed through a filter with certain frequency response. What are the characteristics given, sir? H omega is 2 for certain range, minus b to b, 0 for all other omega. Means it is ideal low pass filter or not? It is ideal low pass filter. We want the exact output. Those who have completed communication subject, you can feel this like demodulation of DSBSC. Very simple model. Demodulation of DSBS. You can think that way, sir. Like demodulation of DSBS. M of t cos omega ct form means DSBSC waveform or not. Anyway, xt cos omega ct multiplied by which term? Cos omega ct plus theta. Later on, they are passed through a filter. What are the characteristics of filter, sir? Its amplitude is 2 for which range? Its amplitude is 2 for which range, sir? -2 to. We want to know exact output. It is stated already omega c is very much greater than b or not? Omega c is very much greater than. If we adjust 1 by 2, 2 cos a cos b, what is 2 cos a cos b here? What is 2 cos a cos b? Cos a plus b one term, another term cos a minus b. Left side adjust 1 by 2, 2 cos a cos b means cos a plus b plus cos a minus b. As omega c is greater than b, 2 omega c is further greater, so this component cannot be passed. Sinusoid is single frequency, this 2 omega c is outside our range. 2 omega c component is outside our filter range because generally carrier frequency megahertz, b is limited to kilohertz only. Second component is passed as it is, so answer is xt cos theta. 1 by 2, 2 cancellations are here. Amplitude of the filter is 2, 1 by 2 cancels each other. As omega c is greater than b, 2 omega c further greater, it cannot be passed. Only second component is passed or not? Only the second component is passed. Good. Generally, in communication, modulation means which filter we are using. Band pass system demodulation means we are going for which filter to recover back our original message signal. We are using which filter? Low pass system or not? Modulation is band pass. Demodulation means low pass filter. Any signal multiplied by cos, sine or complex sinusoid. Any signal multiplied by cos, sine or complex sinusoid is indication of applying which properties are? Frequency shifting or modulation. Frequency shifting or modulation. Let us discuss the next property, differentiation in time. Differentiation in d by dt xt. How we discussed this property in last chapter, Fourier series, 2-3 models we solved. For d by dt, what is the respective multiplier we set, sir, in Fourier series? What is the multiplier we set for d by dt in Fourier series? Jn omega naught. What is the change now? What is the change now, sir? N omega naught replaced as omega or not? N omega naught replaced as, correct? When we differentiate in time domain, the respective magnitudes are scaled by which factor? Mod omega. Take modulus of this quantity. Take modulus or mod omega into mod x omega means the original spectrum magnitudes are raised by how much factor? Modulus of omega. Modulus of omega. What is the disadvantage we mentioned for this property in Fourier series, sir? It may miss the DC component. It may miss the DC component. Correct or not? How 1 by 2 cancelled? 1 by 2, what is the amplitude of the filter, ma? 2 into 1 by 2 becomes what? Here xt by 2 cos theta is applied here. 2 1 by 2 cancellation. It means you cannot say Fourier transform of d by dt xt whole divided by j omega equals to original spectrum. This is not guaranteed. Normally, what is Fourier transform of d by dt xt, sir? J omega into x omega divided by j omega means we should recover back our original spectrum. But it is not guaranteed. Let me explain the reason for you why it is not guaranteed. If I am taking unit step function ut, if I am taking unit step function u of t, what is differentiation of step function, sir? When we are differentiating unit step function, what answer we are getting? Impulse. If I apply Fourier transform here, differentiation of step is impulse. Differentiation of step is, if I apply Fourier transform, j omega x omega equals to 1, x omega is 1 by j omega. Is it a correct answer for step function? For u of t, can you say Fourier transform answer is 1 by j omega? No. You can't say 1 by j omega is the answer. See our first slide. See our first slide. What is ut spectrum standard answer, sir? 1 by j omega plus pi del omega. 1 by j omega plus pi del omega. But what is the answer we got? 1 by j omega only. Why we missed that pi del omega means what is mathematically u0 number we discussed. Come on, friends. What is mathematically u0 number? 1 Fourier transform is 2 pi del omega means 1 Fourier transform is 2 pi del omega means 1 by 2 Fourier transform is what? Pi into del omega. One spectrum 2 by del omega means 1 by 2 becomes pi del omega or not? Why I have written here with another color pen is to say that time differentiation has missed this component. Don't feel we got a correct answer emotionally. Why I have shown with another color pen here is time differentiation has missed that component. Why it has missed that component is, see here everyone. J omega into del omega equals to what is the result? According to product property of impulse, impulse exists at 0. J omega into del omega equals to what is the answer, sir? So whenever the spectrum contains impulse at origin, automatically time differentiation property is missing that component or not? Whenever the spectrum contains del omega, UT formula contains del omega, but property has missed that component or not? Tell me. So the point you have to understand from this example is what? If we apply time differentiation, del omega term is lost. Since, what is the reason? J omega into del omega equals to 0. So whenever our original spectrum contains impulse at origin, don't use the property. It will produce wrong answer. Again, I am explaining, listen. Xt is ut, step function. Differentiation of step is impulse. Differentiation of step is, if I take Fourier transform, j omega x omega equals to 1, sir. We got 1 by j omega, which is the wrong result. For ut, 1 by j omega is not answer. What component is missed? Pi del omega is missed by the property. How it is missed? Mathematically, u0 is 1 by 2. We know 1 Fourier transform 2 by del omega means 1 by 2 spectrum is what? Pi del omega. But what property is doing? J omega into del omega equals to 0 or not? So time differentiation disadvantage is what? Whenever the spectrum has impulse at origin, property is missing that component. Whenever spectrum has impulse at origin, property is missing that component. Okay, del omega component is gone because of this property. You must be careful. Del omega term is lost. So whenever we want to apply time differentiation property in any example, what is the first point you have to check, sir? Whether spectrum at origin is there or not. If it is there, don't use this property because definitely it will miss that term. Definitely it will miss that term. Don't use the property. Okay. Well, please answer me this example. Y of t Fourier transform I have given as y omega. Dyt by dt Fourier transform 1 minus e power minus j omega by 2. I want the signal y of t. Y of t Fourier transform is given as y omega. Dyt by dt Fourier transform also I have given 1 minus e power minus j omega by 2. We want the signal yt. Whatever the spectrum we have, under the property it is multiplied by j omega ma. Suppose our spectrum has impulse at origin, j omega into del omega equals to what is the result? 0 only. If spectrum contains impulse at origin, j omega into del omega result becomes 0 or not? Think and answer me this question. Think and answer me. Yt spectrum y omega. Dyt by dt Fourier transform 1 minus e power minus j omega by 2. My question is, get yt. Think and answer me. Come on, friends. No. Only one fellow responded till now. Wrong answer. Good. Continue your emotions. Zero. No. Dyt by dt Fourier transform is what, sir? Directly j omega y omega dyt by dt. That answer is given as 1 minus e power minus j omega by 2. Listen, it means y omega is 1 by j omega minus e power minus j omega by 2 divided by, according to the formulas we studied till now, for which signal denominator has appeared like j omega? Signum Fourier transform is what? 2 by signum Fourier transform is 2 by j omega. Spectrum extra multiplied by exponential means automatically time shifting property or not? Spectrum extra multiplied by exponential means automatically time shifting or? Come on, friends. So what is the inverse Fourier of each component, sir? 1 by j omega corresponds to half signum. 1 by j omega corresponds to half signum. 1 by j omega again half signum only, but what is T naught numbers are according to time shifting property? What is T naught? X of T minus T naught style. So it is half signum shifted by 1 by 2. Half signum shifted by denominator j omega term is there, means it is linked to signum function. 2 by j omega. Excellent. Most of you have given correct answer only. Very good. It may look like a rectangular pulse for certain length. If you want, draw that graph. Okay. Just for idea. Dyt by dt Fourier transform j omega y omega, sir. Then you solve for y omega, which is 1 by j omega minus this term. As a signum spectrum is 2 by j omega, for 1 by j omega, it becomes what? Half signum. Spectrum generally multiplied by exponents means time domain shifting. Shift of half. Shift of. Good. In the given spectrum, there is no impulse at origin. That itself recognizes. In the given spectrum, there is no impulse at origin. Okay? Very good. Think about this model. Directly x of omega spectrum is given. We want a differentiated signal at origin. Just recollect everyone our theoretical statement. Area under one domain is checking other domain at origin. Area under one domain corresponds to checking other domain at origin. Area under one domain corresponds to checking other domain at origin. We want a differentiated signal at origin means we should integrate the respective spectrum, because we should find out area, sir. If you want differentiated signal at origin, we should integrate the spectrum. What is the spectrum of d by dt xt? J omega x omega, that term we have to integrate. Everyone see here. What is inverse Fourier definition? We know, sir. 1 over 2 pi integral x omega e power j omega t d omega 1 over 2 pi integral x omega e power j omega t. If I differentiate with respect to t, see the cursor. If I differentiate with respect to t, it is differentiation of exponential or not. Automatically, what is the extra multiplier? J omega, of course, that is our property. When we differentiate with respect to t, it is differentiation of this exponential. What is the extra multiplier, sir? J omega into x omega, that is our property or not? As we want d by dt x of t at origin, as we want the term at origin, it is 1 over 2 pi integral of j omega x omega d omega. 1 over 2 pi integral of j omega. Exponential is 1, sir, t plus 0. In our question, what is the range given? What is the range of spectrum, sir? -1 to +1. -1 to d by dt xt at origin. When you are finding one term at origin, area under the respective spectrum. The stupid 1 by 2 pi tag is because of definition. You must be careful. Okay? Think and answer me. Basic thought I have given. Spectrum range is covered from -1 to 1. J omega into x omega area we have to find out. Good. Only one fellow till now positive response. Don't feel emotionally answer 0 gone. I am not asking area under original spectrum. It is hard. But x omega extra multiplied by which terms are j omega. Be careful. 1 by 2 pi -1 to 0. -1 to 0 range. What is the amplitude given, sir? J omega into minus j root pi d omega. J omega and x omega amplitude minus j. 0 to 1 range. J omega into j root pi. J omega into j root pi. Integral omega becomes omega square by 2 or not? J square is -1. Integral omega becomes omega square by. Substitute the limits and simplify. -1 by 2 root pi is the answer. -1 by 2 root. Don't feel emotional. It is area under original spectrum. J omega extra multiplier is there. Observe that carefully. J omega into x omega. So -1 to 1 range our spectrum covers. -1 to 0 its amplitude minus j root pi. 0 to 1 range what is x omega amplitude plus j root pi. Simplify. -1 by 2 root pi. If it is asked for d square by dt square of x at origin, what will happen, sir? If it is asked for d square by dt square of x at origin, right side j omega whole square or not? Right side j omega whole square. Okay. I am going to next point. Frequency differentiation. d by d omega x omega. We cannot compare this property with last chapter. The reason is Fourier series spectrum is discrete. This chapter spectrum is continuous. Frequency differentiation. D by d omega x omega means what will happen in time domain is now the signal is multiplied by minus jt. When you want to differentiate with respect to frequency, time domain, it is multiplied by minus jt. That is not a big deal. What is standard Fourier transform definition? We know, sir. Integral x of t e power minus j omega t dt. Correct or not? What happens if I differentiate with respect to omega here? If I am differentiating this expression with respect to omega, it is differentiation of exponential with omega. Automatically, what is the multiplier? Minus jt or not? Minus jt. If I differentiate with respect to omega, here extra multiplier is minus. That is what our property. Listen. Our previous property is d by dt replaced as j omega. Previous property. Now d by d omega is replaced as what? Minus jt. D by dt replaced as j omega. D by d omega is replaced as what, sir? Minus jt. What is the theoretical statement you can make on the two properties combinedly? What is the theoretical statement you can make, sir? On the two properties combinedly? Come on, friends. What statement you can make? Differentiation with respect to one variable corresponds to differentiation with respect to one variable corresponds to multiplication by other variable. What is the meaning of one variable, other variable here? Time and frequency. When you take d by dt differentiation with respect to time, what is the multiplier? J omega. When you differentiate with respect to frequency, what is the multiplier? Minus jt. Differentiation with respect to one variable corresponds to multiplication by other variable. See, sir, in Laplace, j omega place we are substituting s, sir. Next chapter, j omega place yes. So d by dt becomes s. If I drag that j in the denominator, d by ds is minus t. Same enjoyment with properties. Fourier series to Fourier transform, what is the enjoyment? N omega naught becomes omega. Fourier transform to Laplace, what is the enjoyment with properties? Whatever j omega is there, that is replaced as s or not. Whatever j omega term is there, that is replaced as yes. That is the reason you must be thorough with at least one set of properties. Then you can do modification of variables on your own. You must be thorough with at least one set of properties, sir. Okay? Tell me, what is the Fourier transform for t times e power minus at ut? Which is the known signal for us? Decaying exponentially is known signal. Multiplied by t means other domain, what will happen? It is like txt. Multiplied by t means what will happen in another domain? Frequency differentiation, this property only. Everyone see the cursor? If I take txt, I should multiply both sides by extra j or not? If I take txt, I should take extra j multiplier. Minus j square is 1, right side 1 more j. Right side, left side, j into minus j means plus 1, sir. Right side 1 more j. Otherwise, minus j is 1 by j, cross multiplied. Build up. Everything is same only. So the Fourier transform is j into d by d omega of what is the Fourier transform of decaying exponential? 1 by a plus differentiation of 1 by x becomes minus 1 by x square. Simplify, this is the result. T into x of t means j into d by d omega. j into d by d omega of, very good, 1 by a plus j omega whole square. 1 by a plus j omega whole square. Differentiation with respect to one variable corresponds to multiplication by other variable. Differentiation with respect to one variable corresponds to multiplication by other variable. You also say with me properties, you must habituate d by dt j omega, d by d omega minus jt. Any problem t into something is given, other domain differentiation. Similarly, omega into spectrum is given means other domain differentiation. That is what this theoretical statement stands for. Differentiation with respect to one variable corresponds to multiplication by other variables, sir. Multiplication by other variable. This is a simple differentiation. Don't struggle for that. D by dx of 1 by x style minus 1 by x square, extra j will get minus j square is plus 1. Minus j square it becomes plus 1. Very good. Suppose I have given a signal graph like this. I want the spectrum of this one. Minus 1 to 1, it is a ramp. How to get Fourier transform of that one? How to get Fourier transform? Think. How to get Fourier transform of this ramp signal which covers from minus 1 to 1? Come on, friends. Enjoy whatever the method you love. Enjoy it. I will discuss my technique. I am giving few minutes time for you. How to get Fourier transform of this signal? Slope, differentiation, double differentiation, above, extraordinary. Very good. Good. We can apply both forms of differentiation here. Both forms of course, its slope is 1 only, height by width 2 by 2. Rising ramp. I can take this graph as a simple ramp T, which is there for all times, multiplied by rectangle covers from minus 1 to 1. I can take this as a simple ramp T, which is there for all time, multiplied by rect T by 2. Rect T by 2. T into rect T by 2 is directly this graph or not? T into, everyone see here, what is the Fourier transform for rect T by 2? With our logic, what is the Fourier transform of rect T by 2, sir? Area to SA of omega into positive width. Have you remembered yesterday's class thoroughly? Come on, bachas. Symmetrical rectangle means area first 2. SA of omega into positive width of the rectangle or not, sir? So rect T by 2 spectrum is that. So you can write Y of T as T into rect T by 2. T into, so you should feel this like TXT concept. You can feel this like T, X of T. So once you take Fourier transform, Y omega equals to multiplied by T, other domain differentiation or not, J into D by D omega of original spectrum. Multiplied by T means other domain differentiation, J into D by D omega of SA of X expansion is what? Sin X by X. Sin X by directly that RAM signal extends for the interval -1 to 1, which is the standard finite length signal we know already. Which is the standard finite length signal we know, sir? Come on, brother. Which is the standard finite length signal we know? Rectangle. So T multiplied by rect T by 2. Multiplied by T means other domain differentiation. You should enjoy this simplification. I hope most of you followed differentiation directly. Differentiation of this RAM segment is what? Differentiation of this RAM segment is what, sir? A rectangle that covers from -1 to 1. Anything extra? Differentiation of ramp is rectangle from -1 to 1. What about the jump locations? You have differentiated straight line that has produced a rectangle. What about the jump location? At -1, there is a drop in the level from 0 to -1. See here. See the cursor. At -1, there is a drop in the level from 0 to -1. 1 also. So what extra? What is extra means? Two negative sided impulses at -1 and 1 with weight -1. When we differentiate this RAM segment differentiation is rectangle for -1 to 1. At the point of jump locations, two extra impulses. You must be careful, sir. In hurry, most of you may miss that impulses. Be careful. Be careful. Okay. It means Y dash of T is nothing but rect of T by 2. This signal is rect of T by 2 minus of del of T plus 1 plus del of T minus 1. Y dash T. Differentiation of the signal is original rectangle plus two impulses with negative weight. What is the Fourier transform for shifted impulse? E power minus j omega T naught. Fourier transform shifted. Just use properties and simplification. J omega y omega equals to rect T by 2. Known answer is what? 2 SA omega rect T by 2. Okay, rect. This is e power minus j omega T naught minus 1 e power minus j omega into. So y omega equals to 2 SA omega by j omega 1 term, sir. This is looking like 2 cos or not, e power j theta plus e power minus j theta by 2 means here also when you do differentiation it will look like this answer only. But under time differentiation, what extra care you should take? Jump locations. In a hurry you may miss that. Jump locations. You must be very careful. Okay. Excellent. Some of you have responded. Very good. How omega is there in denominator? अरे बच्चा इधर देखो सैप फंक्शन एक्सपेंशन क्या है? SA of x बोले तो sin x by x है ना? SA of x. Every day is a fresh day for us. कल ही बताया ना? सैफ फंक्शन बोले तो sin x by x है, SCF ओमेगा बोले तो sin ओमेगा by ओमेगा। ये कहां से है, वो कहां से है? सैफ फंक्शन है sin x by x। Yes. Listen, if you want to apply time differentiation, see the cursor, sir. Differentiation of ramp is constant for -1 to 1, which will appear like rectangle. But at -1, we have a jump, negative jump, 0 to -1. At 1 also, we have a drop in the level from 1 to 0, 2 impulses. This is anywhere rect t by 2. These two are impulses with negative weight. So we should apply time shifting also, extra del of t minus t naught Fourier transform, e power minus rect t by 2, 2 sa omega. This can be written as 2 cos omega. Drag that j omega. If you differentiate, these two answers will be same only. That simplification you have to enjoy. Here, u by v rule. b du minus u dv by v square. Like that. Differentiation of u by v rule. Now we are discussing most important point. Actually, in signal subject, there are two signals for which time domain and frequency domain solutions are always same, sir. Only for two signals, the chance is there. One example already we considered in Fourier series. Periodic impulse train is again giving back periodic impulse train. When you take train of impulses, again what we got? Train of impulses. Another such signal is Gaussian function. The spectrum of Gaussian is also Gaussian. The spectrum of Gaussian is also Gaussian function. Very good. Very good. One of you have answered. There are two signals for which time domain and frequency domain solutions will always look like same. Periodic impulse train has produced again impulse train. Gaussian function will give back what for us? Another Gaussian function. Let me explain that point. Listen. If I take x of t as e power minus pi t square, I am taking a specific value instead of e power minus a t square, a number I have chosen as pi. Easy explanation I am giving for understanding. To prove Gaussian spectrum is again Gaussian, we are in need of using two properties. To prove Gaussian spectrum is again Gaussian, we are in need of using differentiation. How we studied, sir? D by dt means j omega. How I can take j omega and f symbol, sir? Omega place 2 pi f r naught. Differentiation is j omega. Omega place 2 pi. How we consider frequency differentiation? D by d omega is what? Minus jt. That is d by d of 2 pi f. Omega place 2 pi f is minus. So d by df means cross multiply 2 pi. D by df means cross multiply minus j 2 pi t. D by dt means, d by df means, so d by dt becomes j 2 pi f, d by df becomes minus j. Because of using these properties, simplified answer we are getting. Rather than omega, I am solving in f symbol because omega symbol requires some standard integral formulas. I want to avoid that. F to omega conversion, bacha, we know omega equals to 2 pi f r naught. F to omega conversion. Everyone tell me, when we differentiate this function, what will happen, sir? d by dt xt equals to what? E power minus pi t square means again same thing into minus 2 pi t. What is the differentiation of minus pi t square, sir? Differentiation of exponentially same term with minus 2 pi t or not? So d by dt x of t equals to minus 2 pi t x of t. Let us assume this as equation 1. Let us assume this as equation. Everyone see here. If I want to take Fourier transform for equation 1, sir, for d by dt, what is our direct replacement? J2 pi f. For d by dt, what is the direct replacement? J2. D by df is expecting what? Minus J2 pi t. One J multiplier is needed. So in equation 1, if I am extra multiplying by J, sir, J into d by dt x of t equals to minus J2 pi t xt. I am multiplying equation 1 both sides by extra J because minus J2 pi t means then only d by df or not. Now you take Fourier transform. Now you take, so J into d by dt, come on. What is the replacement? D by dt means J2 pi f xf. J2 pi f minus J2 pi t. What is the replacement, sir? D by df. So d by df x of f equals to, come on, J square is minus 1 minus 2 pi f. Equation 2. Equation 2. Everyone look at the screen. Equations 1 and 2 are looking like same or not? As equations 1 and 2 are looking like same, compulsory x of f answer must be same as x of t. As equations 1 and 2 are looking like same, x of f answer must be same as, because we got x of t by, we got this first equation by assuming xt as what, sir? E power minus pi t square. As equations 1 and 2 are looking like same, x of f is the same as, x of f is same as x of, therefore x of f is also similar form. Therefore x of f is e power minus pi f square. So to prove Gaussian spectrum is another Gaussian, what properties we applied, sir? Both forms of differentiation, time differentiation and request. Everyone see here. First I assumed xt as e power minus pi t square. If I differentiate with respect to t, original exponential as it is multiplied by minus 2 pi t. That I have written as minus 2 pi t xt. This is xt, sir. I multiplied both sides by extra j component for adjustment of property. For adjustment of d by dt spectrum j2 pi f xf. D by df replacement minus j2 pi t. So as equations 1 and 2 are looking like same, compulsory x of f answer must be same as x of t. But in this case, we proved for a specific number pi. In this case, we proved for a specific number. In general, what is e power minus at square Gaussian spectrum? A is any positive number means root pi by a e power minus omega square by 4a, or root pi by a e power minus pi square f square by a. This is the standard form. Omega place you substitute 2 pi f, that will retain this answer, sir. Omega place. Now how to cross check our answer? E power minus pi t square answer with the standard formula. If I substitute a place pi, root pi by pi e power minus pi f square, answer is same. If I am substituting a place pi, sir, in the general formula I have given root pi by pi e power minus pi f square. Most important observation is area under Gaussian function, if I am asking, this formula we used multiple times at energy power signals. What is the standard answer we know? Root pi by a. How this is correct? Today we are checking. How this is correct, sir? Area under the signal means where you are checking spectrum. Come on, respond. Area under the signal means where you are checking spectrum, sir, at origin. Substitute omega plus 0 or f plus 0. Answer is root pi by a or not? Answer is root. Area under the signal means take the spectrum at origin. Just go through the steps, sir. There are only two signals for which time domain and frequency domain are always same. What are the two signals for which you will feel time domain, frequency domain graphs are same? Periodic impulse train as well as Gaussian function. Gaussian spectrum is Gaussian. Periodic impulse train is again periodic impulse train. Gaussian spectrum is Gaussian. Periodic impulse train is periodic impulse train. Only two signals have the chance. Only whenever integral will appear, what is our immediate thought? Area under one domain corresponds to checking other domain at origin. Area under one domain corresponds to checking other domain at origin. Okay. Never forget in life, what are the two signals for which time domain and frequency domain solutions are always same? Come on, brother. What are the two signals? One is periodic impulse train, the other one Gaussian function. Gaussian spectrum is again Gaussian. Gaussian spectrum is again Gaussian. Differentiation with respect to one variable corresponds to multiplication by other variable. D by dt becomes j omega, d by d omega becomes minus jt. D by dt becomes j omega, d by d omega becomes minus jt. Next, we are discussing a most important property, convolution in time. Convolution in time is what is happening in frequency domain. Convolution in time corresponds to multiplication in frequency domain. Convolution in time corresponds to multiplication in frequency. H of t is called as impulse response. H omega is called as frequency response. Fourier transform of impulse response is called as frequency response. Convolution in time corresponds to शर्मा जी वेट करो, थोड़ी देर में आपको मालूम होता. Rectangle of unequal length. I am solving in few minutes that example. Don't be tensed, brother. Convolution in time corresponds to multiplication in frequency domain. The main application of convolution property is wherever we are using the word filter. The concept of filtering is possible because of this property. It may be ideal filter or practical filter, sir. Wherever we are using the word filter, the concept of filtering is possible because of this property. Everyone listen, don't write anything. Listen here first. If we try to convolve two equal length rectangles. If we try to convolve two equal length rectangles, what is the graph we know, sir? Equal length means triangular. Convolution of two equal length rectangles is triangle. I can write the Fourier transform now as what? Everyone recollect how we have written Fourier transform of the symmetrical rectangle? Area 1. Area 1, SA of omega into positive width means SA of omega by 2. Same thing is repeated means SAS square. Same thing is repeated means SAS square. Here SA omega by 2, here SA omega by 2. AT term is 1. Positive width. Positive width of the rectangle or not? Rectangle Fourier transform SAS function, but a triangle Fourier transform is what? SAS square. Rectangle Fourier transform is SAS function. Triangle Fourier transform is SAS square. In a similar way, पहले सुनो, decaying exponential convolved by decaying exponential. Decaying exponential convolved by decaying exponential. Everyone tell me what is the Fourier transform of this expression, sir? 1 by a plus j omega whole square. 1 by a plus. Just now in the previous slides, we discussed 1 by a plus j omega whole square is Fourier transform of which function? 1 by a plus j omega whole square is Fourier transform of which function, sir? T times e power minus at ut. T times e power minus at. Correct? Decaying Fourier transform 1 by a plus j omega. Here also 1 by a plus j omega. This is spectrum of which function? T times e power minus at ut. Roughly it will appear like this. T times e power minus at. Listen, no tension, listen. This is one combination. Another combination is suppose we want decaying exponential convolved by growing exponential. Decaying convolved by growing, we want to know what is the function. Everyone respond. At least recollect in your mind what is the Fourier transform. First term, sir, 1 by a plus j omega decaying. Second term, 1 by a minus. It means it becomes omega square plus a square. Linked to which function? Denominator omega square plus a square means we want 2a tag in the numerator, two side exponential. We want 2a tag. 2a. So what is the inverse Fourier transform for this function, sir? 1 by 2a e power minus a mod t. 1 by 2a e power minus a. If you convolve a decaying and growing exponential, resultant is two-sided. If you convolve decaying and growing exponential, resultant is two-sided exponential. In a similar way, what is convolution of Hilbert transform with itself? Yesterday under duality we studied 1 by pi t as Hilbert transform. What is the convolution of Hilbert transform with itself? See here everyone. What is the Fourier transform we derived? There is minus j signum omega whole square. Minus j signum omega into same thing, sir, which is simply j square. Signum whole square is plus 1 or not? J square is minus 1. What is the inverse Fourier transform of minus 1, sir? Constant in frequency domain means time domain what? Impulse. So when two Hilbert transforms are convolved, what is the answer? Minus del of t. In a similar way, what is SA function sin a t by pi t convolved with itself? If you are convolving sin a t by pi t with itself, Think and tell me. Sin AT by pi t convolved with itself. What will be the answer? Sin AT by pi t convolved with itself. What will be the answer? I am asking time domain answer. Time domain. Answer is same SAP function only. Same function, sir. Because what is the Fourier transform of sin AT by pi t? Take a rectangle from minus a to a. Take a rectangle from minus a to multiplied by another rectangle from minus a to a. Product of two rectangles means rectangle or not? 1 into 1 becomes 1 only. Don't take emotionally triangle. We are multiplying here, frequency domain multiplication. 1 into 1 becomes, of course, this is neatly Fourier transform of which function for us? SAP function. Convolution of SAP function with itself is same thing. Convolution of SAP function with itself is same thing. If I am substituting a place pi, it becomes which pulse? If I am substituting here a place pi, sir, it is sync pulse or not? Sync t convolved sync t sync t. If I am substituting a place pi, it becomes sync pulse. Sync t convolved sync t is sync t. In a similar way, we can also show that convolution of Gaussian function with itself is another Gaussian function. In few minutes, I am solving that as problem. So I have written theoretically. Ga means Gaussian. Convolution of Gaussian function with itself is Gaussian. According to the few problems I solved under convolution, see here. When you convert convolution to multiplication, only in 2 steps we are knowing the time domain function as they have predefined spectrums. As they have predefined spectrums, only in 2 steps we are deciding the answer. But if you recollect our second chapter, what overaction we have done there? General convolution, graphical method, folding, shifting, multiplication, integration. Start today, tomorrow is the answer. Correct? Which is time waste. Which is time waste. Any signal Fourier transform is there means automatically we can decide the output result easily or not. Convolution of two equal length rectangles, triangles are. As rectangle Fourier transform is SA omega by 2 product. It's same thing SA square. Decaying with decaying is t times e power minus at ut. Like that the other combinations. Like that the other combination. Convolution of SAP function with itself is SAP function only. Convolution of SAP function with itself is SAP. If you substitute a place pi, it can be treated as sync pulse. It can be treated as sync pulse. So few examples I am solving on convolution. Be ready. Few examples. In my observation, competitive exams fellow favorite properties are, but don't study emotionally only that properties. Both forms of shifting, both forms of differentiation, convolution and Parseval's theorem. There are so many properties. Every chapter has 10 to 12 properties, sir. But the favorite properties for competitive exam fellows is both forms of shifting, time and frequency shifting, time differentiation and frequency differentiation, convolution and Parseval's theorem. Convolution and Parseval's theorem. Ga means not SAP. Arey, beta, Gaussian. Because of my laziness, I have written shortcut manner. Ga. Gaussian. SA function. SA means I will write in stylish manner, na? What, brother? Gaussian, sir. This we are solving in few minutes as an example. So that is the reason I have written theoretical. Let us discuss some models related to this. Today's class ending, I will give some homework problems. Listen the property carefully. On this property only, I am giving some examples for you. Today's class ending. So I am going to the next slide. Just a minute. Yeah. Study this question and answer me. An LTI system is having impulse response. H of t equals to sine 4t by pi t. Sine a t by pi t means rectangular spectrum or not? Sine a t by pi t means rectangular spectrum. If the input is cos 2t plus sine 60, find the output. Very funny and simple question. Input sinusoidal means what is the output answer, sir? Whenever the input is sinusoidal to LTI system, output is guaranteed to be sinusoidal. Enjoy. Very easy question. Input sinusoidal, output sinusoidal. Cos 2t plus sine 60 is the input given. What is the spectrum of sine 4t by pi t, sir? A rectangle that covers from -4 to 4. A rectangle that covers from -4 to 4. Every one of you know it is an ideal low pass filter or not? It is ideal. What are the input frequencies we have? 2 and 6. Cutoff frequency 4 means which component is passed? Cos 2t is passed. Fourier series also 2-3 models we solved like this. But there we have multiple sine and cos functions. There we have multiple sine and cos functions. Input sinusoidal means output sinusoidal. Cool. The two frequencies that are given are 2 and 6. Cutoff is 4. So first component is passed. No need to take emotionally x omega and sketching the spectrum. Suppose only sine 60 is the input in this question, sir. Suppose only sine 60 is the input. No cos term. If you have applied only sine 60 as the input, then what is the output? Filter cannot pass, output is 0 or not. When you are applying only sine 60 as the input, filter cannot pass it. Sine 60 input means output becomes 0. Output becomes same problem. I have done small change. Same example. I changed the input now. Sin omega 1t by pi t plus sin omega 2t by pi t. I want to give input as sum of two SAP functions. Omega 1 less than omega 2, which is passed through ideal low pass filter only. Find the output for different cases. Find the output for different cases. 0 less than omega f less than omega 1 less than, like that. Different conditions are given. Find the output for different cases. Input is not sinusoid now. Input is SAF function. Sum of two SAF functions. Tell me in the first case what is the output under the first condition. Zero less than omega f less than omega 1. Input we are giving as sin omega 1t by pi t plus sin omega 2t by which is passed through a rectangular spectrum which covers from minus omega f to each case decide the output. Each case decide the output. It is also stated in the problem omega 1 less than omega 2. This is also mentioned. So to solve this type of questions, let us take some numbers. I am fixing omega 1 as 1, omega 2 as 2. If omega 1 is 1, first rectangle covers from minus 1 to 1 or not, sir? I assumed omega. Better you write down here. Otherwise, you will eat my brain later on. Omega 1 is 1 and omega 2 is 2. For understanding, I am taking some numbers. Omega 2 is 2 means that rectangle covers for what range? Minus 2 to 2. Both are added to pass through this rectangle. Frequency domain, rectangle multiplied by rectangle is rectangle only. But first case, what is our assumption? Omega f less than omega 1. I assumed omega 1 as 1. If I take omega f as 0.5, if I am assuming omega f as 0.5, first rectangle as it is passed till which frequency? Till 0.5. See here everyone, first rectangle as it is passed till 0.5. Second rectangle is also passed till 0.5. Means what is the output answer? Both are retained till 0.5 means sin omega ft by pi t with amplitude 2. Why the amplitude becomes 2, sir? First one is passed till 0.5, second one is also passed till 0.5. 1 plus 1. This is passed, this is passed. Both are passed till 0.5 or not. This is an ideal low pass filter that has some band of frequencies. Don't feel like our previous example, sinusoid single frequency. Now I changed the input as SAF function. Both can be passed till omega f means till 0.5. Most of you have given emotionally 0 answer, gone. That is the reason immediately I have chosen that model, sir. Pure sinusoid is single frequency. SAF function has a band limited spectrum. It is passing certain range or not? Band limited spectrum. So first case, when cutoff is less than omega 1, when cutoff is less than, both can be passed till omega f. Second case, what is said? Now cutoff lies between omega 1 and omega 2. Between 1 and 2, if I choose a number like 1.5 for your understanding, between 1 and 2, here only I am doing that modification, sir. See everyone. Between 1 and 2, suppose I have taken a number like 1.5. Suppose I have taken a number like 1.5. Now you tell me, first rectangle as it is passed, because it is covering till 1 only. First rectangle as it is passed. Second rectangle is passed till 1.5 only. First frequency as it is passed, second one passed till 1.5. So what is the output in the second case? First one as it is passed means sin omega 1t by pi t. But the second one is passed till 1.5 means sin omega ft by pi t. Correct? Sin omega 1t by pi t plus sin omega ft by pi t. What is the last case we said? C. Omega 2 also less than omega f. Second frequency is also less than cutoff. Second frequency is also less than. What is second frequency number I have chosen? 2. Suppose I am assuming 2.5 omega f. Omega 2 less than omega f. Both are as it is passed. Both are as it is. So last case output equals to input. Output perfectly retains both SAP functions are not. So to solve this type of questions, best thing is choose your own numbers. I assumed omega 1 as 1, omega 2 as 2 such that easily we are deciding or not. First case, I felt omega f as 0.5. Second case, I assumed omega f as 1.5. Last case, I assumed omega f as which number? 2.5. Own numbers such that you can decide which components are passed or not. Which components are passed. Very easy problem. But first case, definitely most of you will give wrong answer. It is my assumption, ma. As omega 1 is 1, omega 2 is 2. First case, it lies. Omega 1 must be, omega f must be less than omega 1. Less than 1, I have chosen 0.5 first case. Second case, 1 and 2, between 1 and 2, I have chosen 1.5 to observe which components of the input are passed. It is my assumption. If you want another number 2, 3, enjoy, no problem. Take your own number. For easy explanation, I have taken like that. Good, good. Most of you have answered. Very good. Well tried. First answer me first bit. Second bit I will discuss. Answer me the first bit. Find the output of the system having impulse response sync pulse when you apply input as cos pi t. Input signal cos pi t. System is given as 8 sync of 8 into t minus 1. Yesterday only what I discussed with you. Whenever sync function or SAP function is given, immediately it must be converted to which style in time domain, sir? Sin EAT by pi t. Sin EAT by pi t. Enjoy. Make a try. Convert that to like sin AT by pi t form. This is expanded as 8 sin of 8 pi into t minus 1 by 8 pi into sync x is sin pi x by pi x. 8 jump without the delay, without that 1 unit delay, sin AT by pi t form means where the rectangle covers are. Without the delay, rectangle covers from minus 8 pi to as shift is 1 unit, extra multiplier e power minus j omega t naught as a shift is 1 unit. Try to expand sync pulse sin pi x pi x 8 cancellation without delay. It is sin 80 by pi t means rectangle from minus 8 pi to as delay of 1 unit is there e power minus j omega t naught. What is the input frequency for us? Pi. Sinusoid. Input frequency pi. Cutoff frequency 8 pi. Input frequency pi. Cutoff frequency 8 pi means it is passed or not. So output answer is cos pi t minus 1. Why I am writing t minus 1? System delayed means output delayed version of input. Just recollect convolution. Input shifted by alpha, system by beta. What is the overall shift we have written, sir? Alpha plus beta, that logic. As the system is causing delay of 1 unit, output is delayed version of input. Output is delayed version of input. That is the first bit answer. Instead of giving sin a t by pi t, build up is sync. Try to expand that sync to sin a t by pi t form. Then you can say the answer. Second bit is input is given as e power minus pi t square, which is applied to matched filter. Generally, matched filter is folded and shifted version of original pulse signal. That is what we are learning in communication. The impulse response of matched filter is folded and shifted version of the signal. But here nothing is mentioned about delay, sir. So it is simply folded version. What is the folded version of Gaussian function again? Same thing. Finally, he wants Fourier transform of output. Input Gaussian. It is passed through matched filter. Matched filter job is matching to the input with folding and shifting, but nothing is mentioned about delay. So automatically, it is same as original signal. He wants Fourier transform of output. Tell me out of the 4 options which is correct answer. Out of the 4 options which is correct answer, sir. We want the Fourier transform of output. Come on. Out of the 4 options in the second bit, B bit, which is correct answer? Option D is correct. Very good. Some of you answered. What is the Fourier transform of input, sir? Just now we derived Gaussian spectrum is what? Gaussian. H of f also what? Gaussian. E power minus pi t square. We derived in which slide? 8th slide. Just now we discussed e power minus pi t square spectrum is e power minus pi f square or not? Same logic. So output spectrum is input spectrum multiplied by system response. E power minus pi f square into e power minus pi f square. A power m into a power n means a power m plus n. A power m into a power n means a power m plus n. So what is the correct answer? E power minus 2 pi. This is what I have written theoretically just now. Gaussian convolved by Gaussian is Gaussian function. Gaussian convolved by Gaussian is generally matched filter concept is it is folded and shifted version of original signal, but nothing is mentioned about delay, simply folded versions are. In the problem statement, nothing is mentioned. This is what we have written theoretically. Gaussian convolved by Gaussian is Gaussian. Gaussian convolved by Gaussian is okay. Gaussian convolved by Gaussian becomes again Gaussian function. Try to answer this model. The time function xt corresponds to Fourier series spectrum like this. Maybe it is very light, not visible for you. Neatly I am writing, sir. E power minus pi into f minus 1 whole square shifted Gaussian spectrum is given in the problem. He wants the nature of the signal. Is it real signal or complex signal? Is it even signal or odd signal? That you have to say. Is it real signal or complex signal? Is it even signal or odd signal? Out of the given options, you tell me which is correct. Previous example, some fellows have a doubt. Let me repeat it. Input is given as Gaussian. We proved that Gaussian spectrum is Gaussian or not, sir. Here it is stated it is passed through matched. H of t is a filter matched to GT. Matched means matched filter job is system will match to input signal. Generally, matched filter concept in communication we are learning as folded and shifted version. He has neglected the delay. What is the folded version of Gaussian again? Same thing. He wants finally spectrum of output. Output spectrum is what? Input spectrum multiplied by system response. So a power m into a power n is a power m plus n. Output spectrum is asked, sir. Last option. Decide this question. Shifted Gaussian spectrum is given. Is it real or complex? Is it even or odd? See here, every one of you, last 15-20 minutes, our enjoyment is on Gaussian only. You know that Gaussian inverse is again Gaussian, but spectrum has caused 1 unit of shift. So here we need application of modulation property also. F minus FC form. F minus spectrum is shifted. Spectrum is, so what is the inverse Fourier transform of this one, sir? For e power minus pi f square answer it is e power minus pi t square. For e power minus pi f square, e power minus pi t square, as FC number is 1, e power j 2 pi t. E power minus pi f square is e power minus pi t square, e power j 2 pi fct, fc is 1. E power j theta is there means is it complex or real? E power j theta is there means complex. Then you have to check whether it is obeying even conjugate or odd conjugate. Just recollect our introduction. What happens if I replace t as minus t here, sir? E power minus pi t square minus t whole square is t square. E power minus j 2 pi t. Directly t place substitute minus t whole square is t square e power. Conjugate ले लो. E power minus pi t square into e power j 2 pi t. X of t equals to x conjugate of minus t means we are calling that as which behavior? Conjugate even behavior. Xt equals to x star of minus t means conjugate even or not? Xt equals to x star of conjugate even behavior. Conjugate even. Suppose that fellow has given just e power minus pi f square. Suppose that fellow has given only e power minus pi f square. Then what is the enjoyment? If only e power minus pi f square is given, sir, what is the enjoyment? For e power minus pi f square, answer is e power minus pi t square, which is real and even or not. If only e power minus pi f square is given, time domain it is e power minus pi t square real and even. If this shift one unit is not there, only e power minus pi f square is given, time domain is e power minus pi t square, answer is real and even. Answer is real and even. Okay, I'm going to next model of convolution. Please answer me these bits. Study the question properly. Using convolution property of Fourier transform, find the convolution of the given signals. First bit you answer me, second bit I will tell you directly. Take the spectrum of the signals. Rect t convolved cos pi t is asked. Rect t convolved cos pi t. Rect t convolved cos pi t. Don't feel ABC options, bacha. Each is a problem here. Using convolution property of Fourier transform, perform the convolution of the signals is the question, sir. Rect t convolved cos pi t. Everyone take Fourier transform for the individual signals. Second bit answer I will give. First bit you answer me first. Rect t convolved cos pi t. I will give that formulas also which you require. A rect t by t spectrum is AT SA omega t by 2. That is one thing. Cos omega naught t spectrum is pi into del of omega minus omega naught plus del of omega plus these two spectrums. A rect t by t means AT SA omega t by 2. Cos means pi into 2 shifted impulses. Come on. I want the time domain function. What is the time domain function answer I want? Come on, friends. Make a try. No. Carry 2 pi rect cos pi t. Are we doing convolution or simply multiplication of them, bacha? No. Three steps it will be completed. Only 3 steps. Fourier transform of rectity is what? SA omega by 2 into this convolution becomes product. Cos pi t spectrum is what? Pi into del of omega minus omega naught plus del of omega plus spectrum multiplied by impulse means product property or not. X omega into del of omega minus omega naught is what on the right side? X of omega naught into del of omega minus spectrum multiplied by impulse means product property. Everyone see here? SAP function is sin x by x. SAP function is. So first time omega place which quantity we are substituting? Sin pi by 2 by pi by 2 pi into del of omega minus pi directly in the spectrum. SA omega by 2 is like x omega. There omega place pi plus sin minus pi by 2 by minus pi by 2 pi into del of omega plus. Simply replace omega as plus pi and minus pi. What is sin pi by 2 by pi by 2, sir? 2 by pi. Here also 2 by pi. 2 by pi is common multiplier. Pi into del of omega minus pi plus pi into del of. Every one of you can recognize bracket term is Fourier transform of which function? Cos function. Bracket term is Fourier transform of which function? Till here everybody will write. After that only story is there. Any term multiplied by impulse means which property comes into picture, sir? Product property of impulse. This is product property of impulse. Apply. So when you apply product property of impulse, SA omega by 2 is checked for which frequencies plus pi and minus pi. Both have created same scaling factor 2 by pi or not. This term and this term they are simplified as 2 by pi. Bracket term is Fourier transform of which function? Cos function. Oh, who is this fellow? Rect t minus pi t. What is that? Cos pi t is the answer. Some fellows emotionally they have given second bit answer as first bit answer. Second bit answer is 0. Emotional fellows, advanced. Why second bit answer is 0? Rect t. Again, one of the function is same. Rect t convolved cos 2 pi t. Cos 2 pi t means this SAP function is checked for which frequency? SAS spectrum is checked for which frequency? Plus 2 pi and minus 2 pi. If you substitute omega as 2 pi or minus 2 pi, see the cursor. Result is 0 or not, sir? Second bit without solving, answer is 0 because rect t spectrum is this term. Omega place you substitute plus 2 pi or minus 2 pi, result is 0. Result is 0. Think about the third bit, everyone. What is the third bit asked? Sinc t convolved sinc t by 2. Make a try, sir. Third bit is sinc t convolved sinc t by 2. It must be converted to our style sin a t by pi t. Sin a t by, carry on. Make a try. Sinc t convolved with sinc t by 2. I want the answer for third bit. Sinc t convolved sinc t by 2. Sinc t by 2 is the answer. See here. Sin pi t by pi t convolved with sin pi t by 2 by pi t by 2. Everyone take Fourier transform of individual functions. Sin a t by pi t means first time where the rectangle covers there. Sin a t by pi t means first time where the rectangle covers minus pi to pi with amplitude 1. Here also sin a t by pi t 2 extra or not? Sin a t by pi t 2 extra. That is another rectangle covers from minus pi by 2 to pi by 2 with amplitude of 2. With amplitude of sin a t by pi t means rectangle from minus pi to pi. Here also sin a t by pi t 2 extras are. What is the product of these two rectangles? If you are multiplying them in frequency domain, we are retaining smaller rectangle with amplitude of 2. What is the inverse Fourier I can write here? 2 sin a t by pi t. A number pi by 2. 2 sin a t by. You drag that pi 2 also in the denominator. That is looking like sinc function or not. If you drag the 2 also in the denominator, that is looking like sinc function or? Come on, friends. This particular question is asked multiple times in competitive exams like this. You want to convolve two sinc functions with frequencies alpha, beta. You want to convolve two sinc functions with frequencies alpha, beta. Resultant is also another sinc function with minimum alpha, beta or maximum alpha, beta. You have selected two sinc functions with frequencies alpha, beta. Resultant is also another sinc function with minimum frequency or maximum. Out of pi and pi by 2, which frequency we have written, sir? Pi by 2. Means minimum of alpha, beta. Minimum of alpha. X of t sin alpha t by pi t. H of t sin beta t by pi t. Then the output is k sin gamma t by pi t. Gamma, some other frequency where gamma is minimum of alpha, beta. Minimum of alpha, beta. Based on this problem only, I have given that conclusion. When you select one frequency alpha, another frequency beta, resultant is a function with minimum frequency pi by 2 we have written or not? Minimum of alpha, beta. Minimum. We are retaining minimum frequency. What is the last bit asked, sir? In this question, last bit. Sinc t convolved e power j3 pi t sinc t. At least now you respond, brothers. Sinc t convolved e power j3 pi t sinc t. Come on. What is the answer? That 2 only I dragged in the denominator. Prajapati, idhar dekho. Rectangular spectrum bole to sin a t by pi t. If I drag that 2 in the denominator, sin pi x by pi x is syncable, sir. Sin. Drag the 2 in the denominator, sin pi x by pi x becomes sinc x. What is the last bit answer? Come on. Good. Most of you have given correct answer. 0. What is the reason? No overlap of the spectrums. Signal multiplied by exponential means frequency shifting. Signal multiplied by exponential means frequency shifting. Here application of two properties. Sinc t Fourier transform is a rectangle from minus pi to plus pi. Minus pi to plus pi into signal multiplied by exponential that will cause shift of how many units? 3 pi units. Same rectangle right shifted by 3 pi minus pi to pi right shifted by 3 pi means it extends from 2 pi to 4 pi. What is the product of both the? What is the product of them? Answer is 0 or not. Sinc t means minus pi to pi known spectrum. Signal multiplied by exponential means right shift. If you shift the spectrum right by 3 pi, 2 pi to 4 pi, it covers. Product is 0 or not? Product is all these problems. What is the point you have to understand? 4-5 slides we solve different questions. Whenever you convert convolution to multiplication, if you have a predefined spectrum of the signals in 2 steps only, problem is over. There is no need of unnecessary overaction graphical technique, folding, shifting, multiplication and integration. Once a signal has a predefined spectrum, hardly 2 or 3 steps are needed to know the overall output or not, sir? To know the overall output. The next property which we are choosing is called as frequency convolution. You want to convolve in frequency domain, so now it becomes multiplication in time. x1t multiplied by x2t means 1 over 2 pi x1 omega convolved x2 omega. Multiplication in time corresponds to convolution in frequency. Never forget 3 statements related to shifting properties, sir. 3 theoretical statements I am saying. One property we studied is shift in one domain corresponds to multiplication by exponential in other domain. Shift in one domain corresponds to multiplication by exponential term in other domain. Differentiation with respect to one variable means multiplication by other variable. Differentiation with respect to one variable means multiplication by other. This is the last one. Convolution in one domain becomes multiplication in other domain. This particular property has 2 applications. One application is it can be used as modulator. Its second application is to get samples in frequency domain. Also we require this property. Sampling theorem proof is linked to this property. When we are discussing sampling theorem derivations, all the derivations are linked to this property. Multiplication in time is convolution in. Yesterday we studied frequency shifting is called as modulation property. Even frequency convolution is also called as modulation property. See here, I will give one simple example. Suppose we want what is the Fourier transform of xt cos omega naught t, sir. According to our yesterday's discussion, what is our emotion? Any signal multiplied by cos sin r exponential means frequency shifting. Without that, you feel xt as one signal, cos as another signal. x1t multiplied by x2t form xt as one signal, cos as another signal. So everyone tell me what is the Fourier transform we should write, sir? 1 over 2 pi xt means x omega convolved. For xt, x omega, sir, convolved. What is cos function spectrum? Pi into del of omega minus omega naught plus del of, correct? xt is like x1t, cos is like x2t. 1 over 2 pi xt means x omega, cos function pi into del of omega minus omega naught, del of omega plus omega. Pi jump. So any term convolved by impulse means shifted by that much amount. X of omega minus omega naught plus x of omega plus omega naught whole divided by 2. This is a modulator. Multiple times you will use in communication subject. Any term convolved by shifted impulse means it is shifted by that much amount or not. Same problem if you solve by frequency shifting also, answer is same. Same problem if you solve by frequency shifting also, answer is same, sir. No change in the answer. Morning, one of our friend called me regarding this only. Brother, you forgot 1 by 2 pi. Regarding this only you have called me. 1 by 2 pi will be there. Don't miss the scaling factors. Especially in signals with scaling factors only, wantedly he will change the options. So what will happen? 2021 becomes 2022. We should learn the numbers in sequence. 20, 21, 22 like that. Be careful. Always be careful with scaling factors. Okay? Even you apply frequency shifting property here, 100% answer will be same, sir. Even you apply frequency shifting property here, 100% same answer only. Answer will be same. Please answer me this question by using this property. I want Fourier transform of sin t into sin t by 2 by pi t square. What is the Fourier transform of sin t into sin t by 2 by pi t square? Everyone recollect what is our forms are mathematical expression sin at by pi t. Sin at by pi t. Do the required adjustments. You can blindly apply frequency convolution property. Do the required adjustment, blindly apply frequency convolution property. Tell me resultant spectrum will appear like what? What is the graph I want? Resultant spectrum graphs are sin t by pi t one term, another term sin t by 2 by t. Sin t by pi t one term, sin t by 2 by t. What we need extra? What we need extra, brother? Phi is needed. Then only we can apply the property or not. Phi is needed. You can feel this like x1t, x2t. So if I take Fourier transform, pi adjustment we have done. Pi adjustment we have done. 1 by 2 pi tag is there from property. 1 by 2 pi tag. What is the Fourier transform? First one, sir. Rectangle covers from -1 to 1. Rectangle covers from -1 to convolved. Write it carefully. Multiplication in time is convolution of spectrums. What is the Fourier transform? Second one, rectangle from minus half to half. What is convolution of unequal length rectangles? We know trapezium. Convolution of unequal length rectangles is trapezium. How to get the limits? Add the lower and upper limits of rectangular spectrums or not? Add the lower and upper limits of rectangles. Mr. Sharma, this is the question you have asked me in Q&A. We want Fourier transform of sin t into sin t by 2 by pi t square, sir. Convert to our style, sin a t by pi t style. Sin a t by, for that we have done pi adjustment, sir. This is spectrum formula. Pi adjustment we have done 1 by 2 pi because of property. What is Fourier transform of individual function? They are rectangles. Convolution of two unequal length rectangles, what we studied, trapezium or not? How I have written the x-axis limits? Adding the lower and upper limits, minus 1 plus minus 1 by 2, minus 1 plus 1 by 2, like that. Adding the lower and upper limits of rectangular spectrums. So when you want to multiply in time domain, what will happen in frequency domain? What will happen in frequency domain, sir? Convolution. So without unnecessary build-up, multiplication in one domain is convolution in other domain. Multiplication in one domain is convolution in other domain. Okay, take a short break, 20 minutes. Take one short break. Okay, everyone came back. So today, from the starting, we discussed two forms of differentiation as well as two forms of convolution property. That is time domain differentiation, frequency domain differentiation, as well as time domain convolution, frequency domain convolution. Till now. Let us discuss the next property in Fourier transform, which is integration in time. It is integration in time. What is that property is integral x of tau d tau is having spectrum as x omega by j omega plus pi into x into del omega. Like time differentiation is multiplied by j omega. Don't have a wrong thought. Integration means simply divided by j omega, sir. There we lost the DC value, but here we are retaining DC value. This extra term reflects any non-zero average value that is present because of integration. This extra term reflects any non-zero average value that is present because of integration. So whenever we are applying integration in time domain property, spectrum at zero is there means we have to add this additional term. Spectrum at zero is there means we have to add this additional. But under time differentiation, we lost the DC or not? Under time differentiation, we lost the DC. Let me give an example. Suppose we have chosen impulsor. What is the Fourier transform of impulse we know? Fourier transform of impulse is 1. What is spectrum amplitude at 0? At 0 also it is having amplitude of 1 or not? Substitute this data in the property. Substitute this data in the integral minus infinity to t del tau d tau. Integral minus infinity to t del tau. X omega by j omega means 1 by j omega. X omega answer is 1 plus pi into spectrum at 0 is 1 into del omega. X omega by j omega means X omega answer 1, sir. Spectrum at 0 is 1. Every one of us know integration of impulse is treated as which function, sir? Step function. For ut, this is a correct formula or not? 1 by j omega plus pi into del omega is the correct spectrum. But today starting under time differentiation, what is the only component you got? 1 by j omega. We have not retained pi del omega, correct or not? So integration property will take care of DC value, average value, whereas time differentiation is not taking care of that. Time differentiation, we lost it. Time differentiation, we lost that component, but integration property is taking care of that or not? Integration property is taking care of. And one more simple observation we have to make here is, if I am assuming ut as yt, this becomes y omega. Let us draw the spectrum. Let us draw the modulus of y omega. Anyway, we have an impulse with weight pi. Impulse is always dealt with area that we know. The other term is 1 by j omega. 1 by What is the nature of 1 by j omega? As omega increases, 1 by omega decreases. As omega increases, 1 by omega decreases. Correct or not? So for which frequencies more amplification is done, sir? Lower frequencies we have the peak level, higher frequencies negligible level or not. So integrator is amplifying which frequency components? Low frequency components. That is the reason generally integrator is called as which filter? Low pass filter. Differentiator is high pass filter. Integration is amplifying the low frequency components of the signal. Integrator is going to amplify the low frequency components of the signal. Differentiator means it is amplifying the high frequency components of the signal. So whenever we want to apply integration property, what is the first point we have to check? Whether spectrum at 0 is defined or not. If it is defined, what is the additional term to be added? Pi x0 del omega. Same signal I considered only for cross verification. Under time differentiation, we got wrong result. Under time differentiation, but by applying integration property, we got correct answer or not? Result is correct. When we look at the spectrum, low frequencies, more amplification is done compared to high frequencies. That is the reason generally integrator is called as which filter? Low pass filter. Integration is called as low pass filtering. Differentiator is high pass, integrator is low pass filter. Don't have a wrong thought as differentiation is multiplied by j omega. Integration means simply divided by j omega. There we lost the DC. Here we are retaining that component pi x0 del omega, sir. Pi x0 del of omega. Weight of the impulse is pi. 1 by omega curve magnitude is as omega increases, 1 by omega decreases. This extra term reflects in the property any non-zero average value that is present because of integration. This extra term reflects any non-zero average value that is present because of integration. Differentiator is high pass filtering. Integration is low pass filtering. In one of the old GATE paper, a simple model was asked on this property. What is it is? Simple problem. G of omega is given like this. Omega into e power minus, and y of t is taken as integral g of tau d tau. Y of t is taken as integral g of tau. Then what is the value of integral minus infinity to infinity y of t dt? What is the meaning of this last quantity, sir? Integral minus infinity to infinity y of t dt means area under the signal. Area under the signal or not? Think and answer me. Y of t is integration of g tau d tau. Then we want what is the value of integral yt dt? What is the value of integral yt dt? Good. Some of you answered. According to integration property, what is integral g tau d tau spectrum, sir? G omega by j omega plus pi into Z0 into del omega, G omega by J omega plus pi into Z0. But in our example, what is G0 answer? 0, gone. This is nothing but spectrum at origin. This is nothing but spectrum at origin. So after substitution, what will happen? Omega into e power minus 2 omega square by j omega at omega equals to 0. Y omega is g omega by j omega. Substitute g omega expression divided by omega jump. Omega plus 0 means answer becomes 1 by j. Answer becomes 1 by. After application of integration property, take the spectrum at origin or not. Area under the signal means taking the spectrum at origin. Take the spectrum at origin. First you have to apply integration property. Later on spectrum at origin. Let us discuss the next property, which is actually called as Rayleigh's energy theorem. Energy signals, its name is Rayleigh's or Parseval's power theorem. Energy signals, the word Rayleigh's is used. Power signals, Parseval's. Even if you say Parseval's theorem, nothing will happen. Don't bother about the name. Rayleigh PDF we are learning in communication. Energy signals, Rayleigh's theorem, power signal, Parseval's theorem. What is this property is, if xt is transform pair with x omega, then integral mod xt square dt means energy or not, sir? Integral mod xt whole square dt equals to 1 over 2 pi integral mod x omega whole square with respect to f symbol integral mod xf whole square df, because d omega by 2 pi is df, d omega divided by 2 pi is. Generally, this magnitude whole square we are taking as the spectral density. How the spectrum is distributed for various frequencies, it is decided by that quantity, sir. How the spectrum is distributed for various frequencies, it is decided by that word spectral density. As we are doing integration area, area under spectral density corresponds to energy or power in the signal. If the considered signal is power signal, both sides add time average. If the considered signal is power signal, both sides add time average. Limit t tends to infinity 1 by 2t here and here. Okay, if the considered signal is power signal. So depending on the nature of the signal, this can be called as ESD or PSD, energy spectral density or power spectral density. Fourier transform whole square is called as spectral density. As we are integrating that quantity, area under spectral density corresponds to energy or power in the signal. Area under spectral density corresponds to energy or power in the signal. Be careful with the word spectrum and spectral density. Just x of omega means spectrum. Just x of omega means spectrum. But a spectrum whole square is spectral density, sir. Fourier transform whole square is spectral density. This 1 by 2 pi is because of its proof. This proof is based on inverse Fourier definition. Inverse Fourier contains 1 by 2 pi tag. That is the reason in omega you will retain 1 by 2 pi here, sir. When you want to prove this property, we will write left side quantity as xt into x star t. In the process of proving that, you will get that 1 by 2 pi tag. Of course, Parseval's theorem is also called as law of conservation of energy. Either you take time domain or frequency domain, energy levels are same. Law of conservation of energy. Let me explain generally what is the significance of this theorem. Why do we require Parseval's theorem? Why do we require Parseval's theorem? I am giving a general explanation. Listen. Most of the spectrums that we have drawn at the beginning of this chapter, roughly they are looking like Gaussian spectrums. Magnitude spectrums are roughly looking like Gaussian spectrums. Once this information is processed through different types of systems, once it is processed through different types of systems, suppose at the output side, if we have detected an output graph, something like this, we are not in a position to recognize what was the original information that is transmitted. Why you got a deviation in the shape is because of the internal components of the system, it may got distorted, or externally noise is added. Because of the internal components of the system, it may got distorted or externally noise is added. Rather than transmitting mod x omega, suppose we want to transmit the input signal energy. Assume roughly the graph is like this. Roughly. Suppose the output spectral density graph, you have retained something like this. Suppose we have retained output spectral density graph like this. Now we have a better visualization in the lower graph. What is that better visualization? Whatever the input energy that is there for a certain band, output side also it is retained as it is. But certain frequencies, high frequencies, it is showing variation in the energy level or not. So spectral density always provides better information compared to spectrum. So in real-time applications, we will never compare spectrums. We will always compare spectral density. The known tool when you are listening to music, you are going to observe visualization tool, Windows Media Player, Winamp. The tool is called as spectrogram. It will show the variation of the song. Y-axis mod x omega whole square versus omega. So certain times more emotion, certain times valley, certain times again more emotion. If they are using high pitch, it will raise. Normal voice, valley type. That tool is called as spectrogram. It is a visualization tool. Whenever you are listening to Windows Media Player, Winamp, any standard music system, you just try to observe that y-axis spectral density versus frequency. In real-time applications, we are always comparing spectral density to observe that how much of the input energy is exactly retained at the output side. The other way of explanation is, see here, sir, everyone. Most of our continuous signals will have amplitude as 1 millivolt to 5 millivolt. Within the channel width, noise voltage is 100 microvolts. Approximately, not exact answer, approximately. When 1 millivolt signal is added to 100 microvolts, which amplitude is dominating means you can't say. But once you take whole square, noisy level is negligible. That is another reason we are going for spectral density. The purpose of using the word spectral density is how much of the input signal energy is retained at the output side once it is processed through different system. If you want to retain these frequencies as it is, we will fix the filter coefficient, system coefficients as 1. If you don't want to retain these frequencies, we'll make filter coefficients as 0. That is actually called as adaptive filter. All this is advanced level. Don't be tense. It is not there in GATE or any exam for you. Adaptive means adjustable coefficients. It is a linear time variant filter. In the noise environment, how to detect the signal means by using this adaptive filter, we are detecting the coefficients. There are two fellows, Wiener and Kalman. They have developed some algorithms like least mean square, recursive least square to find out this filter coefficient. Each is just 5 to 6 pages derivation. After solving that 5 to 6 pages derivation, we are in a position to know what filter coefficients we have to use to get the required output. Leave all that story. Remember only one point. The purpose of learning this Parseval's theorem is what, sir? How much of input information exactly retained at the output side? How much of the input information exactly retained at the output side? To know that, we require this. Okay? Adaptive filter is there at certain place of image processing also, which is a linear time variant filter. Of course, we also know decimator and interpolator are adaptive system because they are changing number of samples or not. Decimator and interpolator are adaptive systems. You must be careful with two words, sir. Spectrum, spectral density. Just X omega means spectrum. But the Fourier transform whole square is called as spectral density. Fourier transform whole square is called as spectral density. Be careful with the two words. So whenever you are unable to find out energy or power of a signal in time, immediately we have to shift to which domain, sir? Frequency domain. Immediately we have to shift frequency domain. The favorite question of all competitive exam fellows, now I am giving answer it. All competitive exam fellows. What is the energy in the signal sin AT by pi t? We want energy in the signal sin AT by pi t. Calculate and tell me, sir. We want energy in sin AT by pi t. If you fail in time, frequency domain, what is the expression? Integral mod xt square dt equals to 1 over 2 pi integral mod x omega whole square d omega. Enjoy. We want energy in the function psi by pi t. Good. Only one fellow has given correct answer in the chat box. What is the Fourier transform of this one? It is not possible to answer that question from time domain. Integral sin AT by pi t whole square means we don't know. But what is its spectrum, sir? Rectangle from minus A to A. I am using the property. This right side quantity I am using. So energy in the signal x of t equals to 1 over 2 pi integral minus A to A spectrum amplitude whole square d omega. Spectrum amplitude whole square A by pi. A by pi is the result. Another observation, if I substitute A place pi, if I substitute A place pi, it is treated as which functions are? Sinc. Integral sinc square dt means energy in the sinc pulse is how much? Directly A plus pi means answer is 1. Yesterday we studied integral sinc t dt is 1 under duality. Integral sinc t dt is 1. Today under Parseval's theorem what we are discussing, integral sink square t dt is 1. Substitute a plus pi, that is sink function. Energy means integral signal whole square. In terms of general form a by pi, if a number is pi, then only it is sink pulsar. If a number is pi, answer is 1 or not. Integral sink square t dt is 1 and integral sink t dt also 1. Your creation started 2a pi like that. Okay. Energy in sin a t by pi t is a by pi. Energy in sin a t by pi t is a by. It is not easy to solve this expression of energy from time domain. Integral of sin a t by pi t whole square means not easy. But spectrum of sin a t by pi t is known for us. So immediately we are using this Parseval's theorem. Integral mod xt whole square is energy. Right side, what are the integration limits now, sir? Minus a to a spectrum amplitude whole square d omega a by pi. If I am substituting a plus pi, it is treated as sink function. So integral sink square t dt means pi by pi is 1. Yesterday under duality we studied integral sink t dt also. So this sin a t by pi t has some properties. See here everyone. It is integrable. Means area under that is finite. Is square integrable. What is the meaning of square integration? Energy is also finite. Normal integration finite, square integration is finite. But the last point, not absolutely integrable. It is not absolutely integrable. It is not absolutely integrable, sir. It is not absolutely integrable. Absolute integration we require as LTI system stability or not. If you take integral of modulus of sin a t by pi t, answer is infinity. If you take integration of modulus of sin a t by pi t, answer becomes infinity. It is not absolutely integrable. Normal integration we checked finite number. Square integration means energy, but not absolutely integrable. But in our competitive exams, they will never give like sin a t by pi t directly, always indirectly only. 1 or 2 fellows, for easiness, they may give directly. 1 or 2 fellows. If the question is asked like this, what is the energy in the signal for sink of t by 5? What is the energy in the signal for sink of t by 5? Enjoy. Give me that number. Not absolute integration means stability integral mod h tau d tau is not finite. Distortionless condition, I'm going to prove that point under distortionless transmission, which is one of the application. For LTI system stability, we want absolute area integral mod h tau d tau. That answer becomes infinity, sir. So it is not absolutely integrable. 4 by 5, confidently wrong answer. Check karo. What is the energy in the function 4 sink t by 5? Come on, friends. This is 4 sin pi t by 5 divided by pi t by 5. Expand. Sinc x is sin pi x by pi x. Expand and solve. Ah, 4 to 5 fellows have given correct answer to me. Good. Very good. This is further. Take 5 in the numerator. 20 sin pi t by 5 by pi t. Our standard style. For which spectrum is what, sir? A rectangle that covers from minus pi by 5 to pi by 5 with how much amplitude? 20 is the amplitude level. 20 is the energy in this signal means 1 over 2 pi integral minus pi by 5 to pi by 5 20 whole square d omega. 20 whole square. Answer is 80 or not? First you draw the spectrum. Minus pi by 5 to pi by 5, 20 whole square d omega. Answer is 80. Two pi is there. Don't get emotion. 1 by 2 pi tag is there, sir. Omega domain. Mr. Venkata Krishna. 1 by 2 pi also we have to introduce. Think and answer me the right side question. We want the energy in the given spectrum. We want the energy in the given spectrum. Think and answer me. That spectrum actually we have to integrate from minus 1 to 1, sir. But because it is even symmetric, 2 times 0 to 1 range. 2 times 0 to 1 range. 1 over 2 pi integral minus 1 to plus 1 mod x omega whole square. This is even symmetric magnitude whole square. So 2 by 2 pi integral 0 to 1 mod x omega whole square. Come on. One by pi 0 to 0.5 range. What is the amplitude level given, sir? Here you see the cursor. Root pi by 2 whole square 0.5 to 1 range. Root pi whole square 1 by 8 plus 1 by 2. You do that simplification. Answer is pi by 8. 1 by 8 plus 1 by 2, that becomes pi by 8. The given spectrum is even symmetric. Given spectrum is even symmetric. Good. Because it is even symmetric, minus 1 to 1 we have made as what? 2 times 0 to 1, sir. 2 times 0 to 0.5 range root pi by 2 whole square. 0.5 to 1 range root pi whole square. I hope you have completed this. Yes. Try for these two models. First, everyone try the left side thing, sir. Find the value of 8 by omega square plus 4 whole square d omega. Left side quantity is looking like integral spectrum whole square. Omega square plus 4 whole square indicates integral spectrum whole square. So observe whether it is possible to answer for you from time domain or not. Sorry, from frequency domain. If you fail in frequency domain, go back to time domain. If you fail in frequency domain, go back to time domain. According to the formulas we learned, which signal has the denominator omega square plus a square? Two-sided exponential. Two-sided exponential. Have a thought? Have a thought? What is the left side quantity answer? So many answers I am getting. Till now, only one fellow correct answer. Till now. Only one fellow, sir. E power minus a mod t is 2a by a square plus omega square. E power minus a mod t is 2a by a square plus omega square. So first we need an adjustment for the given term. Normally 2a by a square plus omega square means 2 into 2 by omega square plus 2 square. Total term whole square d omega. Total term whole square d omega. What I adjusted extra here, 2a by a square plus omega square means two side. Numerator becomes 16. Given multiplier is 8 means what we adjusted extra? 1 by 2 we adjusted. So we are not in a position to answer this question in frequency domain when you apply the theorem. What is the answer in time domain, sir? 1 by 2 adjustment we have done. 2 pi extra multiplication, integral minus infinity to infinity. Two-side exponential means e power minus a mod t whole square dt. Why I have multiplied 2 pi here? Why I have multiplied 2 pi here? See here, integral spectrum square is asked, but we are solving the answer in time domain. So 2 pi must be cross multiplied or not? 2 pi must be cross. As this is even symmetric. Again, minus infinity to infinity can be written as what, sir? 2 times 0 to infinity e power minus 4t dt. Answer is 2 pi by 4, pi by 2. The given term is looking like, denominator is looking like two-side exponential Fourier transform omega square plus a square means two-side exponential Fourier. But in the numerator, we want 2a, sir. After making that adjustment, it becomes 16. Given multiplier is 8 means 1 by 2 adjustment we need. 1 by 2 into 2 pi. Actually, 1 by 2 pi is there in frequency domain, but we are solving in time domain. Cross multiply 2 pi, integral signal whole square. Because it is even symmetric, I have written 2 times 0 to infinity. What is e power minus 2t whole square? E power minus 2t into e power minus 2t means e power pi by 2. What is the difference between this question and 20th slide question? What is the difference in the problems of sin a t by pi t question and this question, sir? In this question, we are not in a position to get the energy from frequency domain. We converted that back to time domain. In the case of SAP function question, we are not in a position to answer the question from time. So we converted to spectroma. It means when you fail in one domain, definitely other domain you will get the answer. When you fail in one domain, definitely other domain you will get the answer or not. Integral signal whole square or spectrum whole square means what is the immediate thought we need, sir? Integral signal whole square or spectrum whole square means what is the immediate thought we need? Application of Parseval's theorem. Other than that, being thorough with standard formulas. Otherwise, you will not answer anything. Okay? You must be careful. If you fail in time, get the answer in frequency. If you fail in frequency, get the answer in time domain. Any one chance is there for us. Okay? Now most of you have corrected. Think about this right side question. Think about the right side question. Symmetrical triangle is given, asked for energy because it is given with F notation. Energy in the spectrum is what normally? Integral mod xf whole square df. Actually, we should integrate from minus 10 power 4 to 10 power 4. But it is satisfying again. So 2 times integral 0 to 10 power 4. What is the mathematical expression for that range? You find out 10 power minus 6 into 1 minus f by 10 power 4. Negative answer. Find out that expression. F plus 0 means 10 power minus 6. F plus 10 power 4 means 0. Square of that 10 power minus 12 into 1 minus f by 10 power 4 whole square df. Do that integral enjoyment. Answer is 10 power minus 8. That stupid integration we have to do. 1 minus f by 10 power 4 whole cube divided by 3 into minus 1 by, but 70 to 80% of the fellows will fail in this triangle ramp expression only. What is the direct logic we know? Just recollect introduction. Width of T, amplitude A, what is energy answer? A square T by 3 logica. So what is the width of the spectrum now? A square is 10 power minus 6 whole square. Width of the spectrum, sir, 2 into 10 power 4 minus 10 power 4 to 10 power 4 means directly we got the answer. If you find the ramp expression, if it is gone, life is gone. You must be careful or not? Tell me. Without that, we have a direct hint. Triangular pulse means A by 3 logic. One of our fellow is asking for rectangle also, you can apply, sir. A square T logic with 1 by 2 pi. Don't forget 1 by 2 pi, it must be there. Because this quantity is energy. A square T logic you can apply for this question also. A square T by 3 is simple rather than enjoying the stupid integration. Rather than enjoying the stupid integration. It is the answer. I used to say for all the fellows, there will be a definite question from Parseval's theorem either in CTFT or DTFT or DFT regularly. GATE 2020 question I am giving as homework for you. With answer. Simplification only I will not discuss. That chance I will give for you. Like this, the signal graph is given. Like this, the signal graph is given, sir. He wants integral mod x omega whole square d omega. If the Fourier transform of that signal is, denoted as x of omega, for this signal he wants integral mod x omega whole square d omega. So right side compulsory, what you have to multiply, sir? 2 pi, it is not there. If you are not multiplied, gone. 2 pi into integral mod xt whole square dt or not. Indirectly energy in the signal. You think of rectangle, triangle style, you think of. One hint is, it is symmetrical with respect to which value in the time domain. With respect to t equals to 1, this half, that half, both are same. This half, that half, both are 56 pi by 3 is the answer. 56 pi by 3. That is the answer. Thinker. No urgency. Any domain we can use, sir. Not time domain or frequency domain. It must look like triangle or rectangle. Any domain also you can apply. Itne bar भेज रहे Tejas? Any domain you can apply. Last year one fellow I think 2 pi missed. That is the reason 2020 became 2021. I told you so many times in the class. Be careful, sir. That is the beauty of signals. With scaling factors only, our life is gone. GATE exam is like IPL. Last ball 6 means you have to hit. Otherwise, next year only. You must be careful. Be careful with scaling factors. Try that model, you will get answer. Answer also I have provided for you. Okay. Later on you try, no urgency. Okay. This is one of good example on this theorem. Again, input signal is given as a decaying exponential e power minus t ut that is passed through an ideal low pass filter with frequency response characteristics. Find omega c such that energy in the output is half that of input energy. Study the question and answer me properly. Shifting in time domain will not change energy, ma. Correct. Shifting in time domain will not change the energy. X of t energy is E, X of t minus 3 energy also E only. After studying this question, the thought you require is which properties to be applied. First, let us write the known information first. E power minus 2t u of t is the input given. That is passed through h omega. What is h omega? It covers from minus omega c to omega c. We are getting some output, but the question is not output. Find omega c such that energy in the output is half that of input energy. Energy in the output is half that of input energy. I will give hint and few minutes time, answer me. Input known, system known, getting the output is not target. If you know input and system to get output, we are using convolution property. If you know input and system get the output means convolution property. As it is related in terms of energy, Parseval's theorem. As it is related in terms of energy, we are applying which theorem, sir? Parseval's theorem. By applying two properties, we are in a position to know the answer. First step, find out the input energy. If you find out the input energy, you will know output energy also. Find out the input energy first. Then you will know output energy also. Find out output spectrum. Y omega you find out. Output energy known, output spectrum known means Parseval's theorem for output. Output energy known, output spectrum known means apply Parseval's theorem for output. First, everyone calculate input energy, sir. First step is calculating input energy. Come on. Calculate the input energy first. Calculate the input signal energy. Energy in the input can be calculated from time domain. 0 to infinity e power minus 2t whole square 1 by 4. Therefore, energy in the output becomes which number? 1 by 8. Half of input energy given. Half of. Second step is output spectrum. Y omega is X omega into H omega. Y omega is X omega into, what is the Fourier transform of inputs are? 1 by 2 plus j omega into filter response 1. As filter is band limited, output spectrum is also band limited. As filter is band limited, output spectrum is band limited. Minus omega c to omega c range. Minus omega c to. We know output energy, we know output spectrum. Last step is what? Apply the theorem for output. Apply the Parseval's theorem for energy in the output equals to 1 over 2 pi integral of mod yf square mod y omega whole square d omega. Apply theorem for output, sir. Left side quantity number is what? Right side integration range is what, sir? Minus omega c2 modulus of 1 by 2 plus j omega whole square. Substitute the known data. Energy in the output 1 by 8. 1 over 2 pi. Y omega range is minus omega c to omega c. As magnitude's whole square is again even symmetric. As magnitude whole square is again even symmetric. 2 pi by 8 cross multiply 2 pi. 2 times integral 0 to omega c d omega by omega square plus 4. 2 times integral 0 to omega c d omega by omega square plus. This integral is looking like which standard formula of maths? Right side. The integral is looking like integral 1 by x square plus a square dx is 1 by a tan inverse x by a. 1 by a tan inverse x by. This formula is looking like this one, sir. Integral 1 by x square plus a square is 1 by a tan inverse. So further it is written as what? Further, left side pi by 4. Right side 2 into 1 by 2 tan inverse of omega by 2 over the limit 0 to omega c. 2 1 by 2 jump tan pi by 4 is 1 omega c becomes 2 radians per second. 2 radians per. How to solve this integral is last step. How to solve the. After studying this question, you need a thought. What thought? Which properties to be applied? Input and system are known, get the output means what? Input and system are known, get the output means convolution. As it is related in terms of energy, sir. As it is related in terms of energy, application of Parseval's theorem for output. Once you got the idea which properties to be applied here, 50% of the question is over. Other 50% is mathematical enjoyment, simplification. Other 50% is only mathematical enjoyment. Okay. So to solve this integral, we use our normal known formula. Integral 1 by x square plus a square dx is 1 by a tan inverse. Here, how to write these denominators are? Omega square plus 4 is nothing but what? Omega square plus 2 square. Omega square plus. I mentioned with you, I will discuss some bandwidth definitions. What is absolute bandwidth of sync alpha T? What is the absolute bandwidth of sync alpha T? Think and answer me. What is the absolute bandwidth of sync alpha T? I want the result. What is sync alpha T expansion, sir? Sin pi alpha T by the spectrum is what? Sin A T by pi T form with amplitude of 1 by alpha, it extends from minus pi alpha to bandwidth is the word used. So absolute bandwidth becomes pi alpha radian mode Hedge scale divided by 2 pi. If you want the answer in Hedge scale divided by omega to F conversion, pi alpha. Take the spectrum pi alpha minus 0 radian mode divided by 2 pi means Hedge scale divided by what is the 3 dB bandwidth of e power minus 4t ut? What is 3 dB bandwidth definition, sir? Half power point frequency. At that frequency, magnitude becomes 1 by root 2 of the value at origin. 3 dB frequency means half power point frequency. At that frequency, magnitude becomes 1 by root 2 of the value at origin. Think of what is the 3 dB bandwidth of decaying exponential e power minus 4t ut? Some of you are answering 2 alpha pi for the previous problem wrong. Bandwidth. I have not used the word spectral width, bandwidth. Strictly for positive range. What is the 3 dB bandwidth of this one, sir? E power minus 4t ut. E power minus 4t ut. I want omega c number. Answer 4. Observe here. What is the Fourier transform of this term? 1 by 4 plus j omega. 1 by 4 plus. So mod h of omega c whole square is mod h0 square divided by 2. What is the magnitude of this quantity, sir? 1 by root of 16 plus omega square. So if I take magnitude whole square, 1 by 16 plus omega c square, magnitude whole square, sir. Mod h0 whole square means 1 by 16 by 2. 16 plus omega c square is 32. Compare the denominators. Omega c becomes 4 radian per. All this is build up which is not at all needed. Every one of you can recognize that it is the impulse response of standard RC filter or not. H of t is 1 by RC e power minus t by RC u of t, impulse response of tau equals to RC, 3 dB cutoff omega c is 1 by RC 1 by tau. The impulse response of RC filter is what? This one, t by tau. Tau is RC, 1 by tau is omega c or not. What is that number directly available? 4. By solving, what you have decided? Answer is 4. No need to waste your time. Unnecessary overaction, no mathematical calculation. Suppose I asked what is 3 dB bandwidth of e power minus 5t ut. Answer is omega c is 5. Answer is omega c is 5. No need to solve. It is the impulse response of RC filter. Impulse response standard expression is what? 1 by RC e power minus t by RC u of t. 1 by RC e power minus t by RC u of t. Okay. See here, RC filter 1 by RC e power minus t by RC. Time constant RC we are learning or not? Tau equals to RC. Omega c is 1 by tau. What is that visible number? It is also looking like same. What is that omega c place? It is there 4. By solving, what you got? Same answer you got. What is the equivalent bandwidth of a Gaussian function? This generally we need in communication. Noise equivalent bandwidth, noise equivalent temperature, Friis formula. In noise topic, we are using that. Listen first, everyone. Equivalent bandwidth is the bandwidth of ideal filter that passes same energy as that of a practical filter. If practical filter response is like this Gaussian spectrum, magnitude response. Ideal filter, every one of us know, is like a rectangular spectrum. Whatever the energy level that is there for ideal filter, the same energy if it is taken by practical filter, that is called as equivalent. The bandwidth that is taken by ideal and practical, so it is the bandwidth of ideal filter that passes same energy as that of practical filter. Same energy as that of practical. So the equivalent bandwidth is defined by this relation. 0 to infinity mod hf whole square df by mod h0 whole square. Whatever the bandwidth ideal system is taking, that energy, if it is maintained by practical filter also, it is called as equivalent bandwidth. It is a bandwidth of ideal filter that passes same energy as that of a practical filter. What is the Fourier transform of this Gaussian function? Already we know, sir. E power minus pi f square means DC component f plus 0, answer 1. So for this given question, 0 to infinity, what is mod hf whole square? E power minus 2 pi f square df, denominator 1. If the integral starts from minus infinity, then only root pi by a result. But integral starts from 0 means 1 by 2 root pi by 2 pi. That is 1 by 2 root 2 is the answer. If the integral starts from minus infinity to infinity, then root pi by a. Because it starts from 0, 1 by 2 adjustment. Root pi by. It is the bandwidth of ideal filter that passes same energy as that of a practical filter. The bandwidth of ideal filter that passes same energy as that of a practical filter. There are different definitions of bandwidth. Absolute bandwidth, 3 dB bandwidth, 90% or 95% bandwidth, equivalent bandwidth. FCC bandwidth is used in communication subject, especially FM. Okay. Don't have a wrong thought. Bandwidth means simply highest minus lowest frequency component. That is a wrong thought. That is a wrong thought, sir. It depends on the context we are using. It depends on the context we are. Till now, we solved some examples related to Parseval's theorem. Examples related to Parseval's theorem. Suppose a question is asked like this. What is the value of this integral? It means it is area under product of two different signals. One signal 12 sync 4t, another signal cos 2 pi t. Listen first, everyone. Parseval's theorem is applicable for same signals. Where we discuss Parseval's formula. Integral mod xt whole square indirect meaning is what, sir? X of t into x star t. Integral mod xt whole square meaning is xt into x star t. Right side mod x omega whole square means x omega into x star omega or not. Like Parseval's theorem is applicable for same signals. Now we are solving this problem by using Plancheral's theorem. Instead of xt into x star t, we will write xt into y star t. If the considered signal is complex, then only conjugation is needed. Instead of xt into x star t, left side xt into y star t. Right side 1 over 2 pi integral of x omega y star omega d omega. If the signal is complex, then only conjugation. In our problem, both are real functions. Sinc function real, cos also real, sir. Same property with respect to f symbol is integral xf y star f df without 2 pi tag. This is called as Plancheral's theorem. Both are P fellows only. Parseval's, Plancheral's, P fellows. So our signals are real here. Our signals are real. X of t, you can assume sync 12 sync 4t as xt. Y of t, no need of star here. The star is taken only for complex signal. Star is taken only for. I have given hint for you. Use the theorem and tell me the answer. Use the theorem. Take Fourier transform for 12 sync 4t and cos 2 pi t separately. Multiply the spectrums. You will retain the answer. Area under product of two signals means Plancheral's theorem. Area under product of two different signals means Plancheral's theorem. Think. I have given hint for you. Assume 12 sync 4t as xt, cos 2 pi t as yt. Think. Take their spectrums, multiply right side 1 over 2 pi integral x omega into y omega. There is no need of star because the considered signal is both signals are real signals. They are not complex, sir. Both signals are real. Only one fellow. Correct answer. Till now. Let me explain. 12 sink 4t expansion is what? 12 sin 4 pi t by 4 pi t. So what is the Fourier transform of this term, sir? Sin a t by pi t means rectangular spectrum covers from minus 4 pi to 4 pi with amplitude 3. Sin a t by pi t form. Cos 2 pi t means what is the Fourier transform of cos function, sir? Pi into 2 shifted impulses. Pi into 2 shifted impulses at plus or minus. This is x omega, this is y omega. When you multiply impulse with itself, impulse is retained at that frequency as it is or not. When you multiply this rectangle with impulse, impulse will be retained as it is with change of weight. With change of weight. So what is the answer? According to the theorem, 1 over 2 pi. See here everyone, 1 over 2 pi, 3 pi into del of omega plus 2 pi, one quantity, 3 pi del of omega minus 2 pi is another quantity. 3 into pi del of omega plus 2 pi, 3 pi into del of. The individual weight of the impulses are 3 pi. Answer becomes 3. Answer becomes area under product of two different signals means Plancheral's theorem comes into picture. Area under product of same signals is Parseval's. Area under product of two different signals is Plancheral's theorem. See here everyone, one more time explanation. See here everyone. 12 sink 4t is like xt, sir. Cos 2 pi t is yt. Take their spectrums. We have drawn the spectrums. Rectangle multiplied by impulse means impulse will be retained as it is at that frequency. 3 into pi, 3 pi. Area under impulse is 1, but what is the weight of each impulse here? 3 pi plus 3 pi by 2 pi. Answer is 3. This question, instead of framing in time domain, they may frame in frequency domain also. This question only. Reverse way like this. Anyway, first let us complete this. Reverse way, they may ask, what is the sink cube f df value area? Integral of sink cube f df. Use previous property hint. Integral xf yf df means time domain. What you can write? If you fail in frequency, go back to time domain. Integral xf yf df means integral xt yt. I can write sink cube f as what's that? Sink f into sink square f df. We can write sink cube f df as sink f into sink square f. You feel sink f as xf, sink square as yf. You feel sink f as xf, sink square f as. So sink f is Fourier transform of a symmetrical rectangle, rect t. Sink square we observed Fourier transform of which function under convolution? Tri t dt. Again Plancheral's theorem only I used. Sink cube f is written as sink f into sink square f. We are not in a position to answer from frequency domain. So I am taking time domain form. Sink f means rect t, sink square f means tri t. Just find out the area under the signal. Rect t graph covers from minus half to rect t. Tri t means where it covers. Minus 1 to, if you multiply these two signals by feeling this as xt, this as yt, what is the product of the signals there? It will look like a home shape or not. When we are bacha, children, We use it to draw home means immediately this emotion or not graph. Just find out the individual areas, area under the rectangle, area under the triangle, that is answer. 3 by 4 you will get, solve it. Area under the rectangle you find out, area under the triangle also you find out. What is the purpose of solving this question for you is, here we failed in frequency domain, we converted to time. But previous examples are, we failed in time, we have converted to frequency domain. Area under product of two different signals means Plancherol's theorem. Here xt into yt forms are, here xf into yf form. Area under product of same signals means, you know, energy or power, that is Parseval's theorem. Area under product of two different signals is Plancherol's relation. Plancherol's. On today's discussion, this is bacha, don't be tensed. Area under rectangle is what? 1 into half. Area under triangle, half base height. Half into 1 by 2 into 1. 1 by 2 plus 1 by 4. Solve karo. Aasan hai. On today's discussion, few examples I am giving. Make a try on today's discussion. I hope you have completed. These slides are everyone. Integral sinc cube FDF. Sinc F is Fourier transform of rectangle, sinc square is triangle, rect t minus half to half, tri t we know. Tri t covers from -1 to 1. After multiplication, they are limited like this. That area is that number. Assignment for today. Find Fourier transform of 15 rect of t plus 2 by 7. I am giving the answer in F symbol, cross check. What is relation between omega and F? Every one of you know. Question 2. Area under x of t equals to 100 sinc of t minus 8 by 30. Area under the signal means where you are checking spectrum. At origin or not? Area under the signal means take the spectrum at origin. Last example. Find the output of a filter with h of t equals to 4 sinc 5t minus 8 to the inputs. Same filter, we are applying different inputs. Tell me output in each case. Sinc function in time domain means what you are taking? Rectangular spectrum or not? Sinc function in time domain means rectangular. Today we solved these models in convolution. If you cross check that slides, you will get the idea. Don't get emotion and don't paste in Telegram, bachas. You are unnecessarily wasting time in Telegram. Only with chatting. First learn the concepts. If I give assignment for you, you should solve. Don't give assignment to another fellow. You should make a try first on your own. With my photo you are pasting. please solve the following problem. What you will do, bacha? First you make a try on your own, sir. Still, if you have a doubt, you can contact me. I will give the logic for you now. Wantedly, I have given questions on rectangle. In one domain becomes SAP function or sync function. Do the required adjustments. With answers I have provided. With answers. Solve it thoroughly. With answers. Okay? Those who have doubts, stay back. Tomorrow we'll continue again. Those who have doubts, stay back. Rest of them, they can leave, sir. Yes.
Hello.
Yes.
Hello, sir.
Sir.
Sir, in Plancheral's theorem, sir, that question.
Which question?
Plancheral's theorem question. 12 sink 40 into cos 2 pi. Yes, sir. Sir, let's say if in exam, instead of t, they given some x. 12 sink 4x plus cos.
What is that?
Sir,
Area
then,
under product of two different signals means Plancheral's.
yes, sir, but we have to consider frequency domain or in time domain, sir, the given signal.
Maths also it will appear here.
Sir?
In general mathematics also it is there. Plancheral's relation.
Okay.
How they will give x with respect to signals, either they will give time or frequency only.
Okay, sir. Okay.
Next.
That's it, sir.
Chalo, enjoy. Yes, sir.
Sir, good evening, sir.
Good evening, sir.
Sir, I have a doubt in stability condition, sir.
Which stability?
Sir, like a question has given y of n equal to log to the base 10 mod x of n, sir.
Mod xn, if it is 0, system is unstable. Log 0 is not defined. Na? You are asking for stability, na?
Yes, sir.
If mod xn is 0, log 0 is undefined and unstable system. Maybe they have given stable, unstable.
Okay, sir. Thank you. That's what my doubt was, sir.
Enjoy. Yes.
Sir. Hello. Hello.
Hello, bolo.
Sir, in 26F page, sir.
1 minute.
26F page, sir.
Previous slide. 1 minute. Yes.
Sir,
Tell
second
me.
step जरा बताओ sir. W is equal to
Here,
WC
normally we are
omega
doing
C
integration.
mod.
This one, na, right side, na?
No, left side. Second step, sir. At omega is equal to
omega
omega C.
Magnitude whole square. I have taken whole square of this term. Omega plus omega c I substituted. Mod h0 square by 2. Whole square of this quantity. What is magnitude whole square of this one? 1 by 16 plus omega square. Na? What is h0? If I substitute omega plus 0, 1 by root 16 for that square. Solve karo.
That time.
Over.
Okay.
Yes.
Hello, sir.
Yes, sir.
Sir, 5F.
5F. Wait. 5F.
Sir, this second question I didn't get.
What is asked in the question? Differentiated signal at origin that fellow want by giving spectrum. What
Yes.
is inverse Fourier definition? We know this is inverse Fourier or not, sir. 1 over 2 pi integral x omega e power j1. If I differentiate with respect to t, right side in the integral j omega is the multiplier.
Yes, sir.
As we want that value at origin, exponential becomes 1. As we want that value at origin, exponential becomes 1. Just I substituted that data. X omega has two different amplitude levels. Minus 1 to 0, what is its amplitude, sir? Minus j root pi. 0 to 1, what is the amplitude? J root pi. After that, you simplify. Integral omega becomes omega square by 2. Substitute karo. This is final answer.
Okay, sir.
Simplification all I left it.
Okay, sir. Sir, one more thing is like basically they will ask more about sink and SAF function only in this topic.
100%. That is the reason I am discussing more examples on that only.
Okay, sir. Thank
Okay.
you.
Over.
Yes, sir.
Chalo.
Thank you, sir.
Hello.
Hello?
Yes.
Yes, sir. In 12F, sir, that question I didn't get. Sir. Can
What do you want in this?
yes, sir. Can you explain it again, sir?
A input we want to give as sum of two SAP functions which are passed through a filter. This is also SAP function in time domain. Under three different
Yes,
cases
sir.
asked for output. So because they are given in general form, for our easiness, mathematically I have chosen a number 1 and 2. First
Okay.
case it is mentioned omega 1 less than omega f is less than omega 1 if I choose 0.5. If omega f is 0.5, both rectangles can be as it is passed till 0.5. Na?
Yes, sir.
At 0.5 meaning is omega f. So 2 sin omega ft by pi t. Next
Okay.
second case, it lies between 1 and 2. I have chosen 1.5. If I choose omega f as 1.5, first rectangle as it is passed, second one is passed till 1.5. That is the reason first frequency omega 1 retained, second one is retained till omega f only. But in the
Okay.
last case, we assumed even the second frequency less than cutoff, automatically both are passed.
Okay, sir.
Rectangle multiplied by rectangle is rectangle only, na?
Okay, sir. Okay.
Next.
Okay, sir.
Right.
That's it.
Yes.
Hello.
Ah,
Yes, sir. Sir, page 28F, sir.
28.
28F, yes, sir.
1 minute. Yes, sir.
Sir, here you took the area of triangle over the rectangle. Sir,
Product of rectangle and triangle.
yes, sir. The right diagram which we were taught. Area
Yes.
of
Yes.
yes.
You take individual areas because I
You took
want
before
solve
whether
brackets.
you told about it.
This area of rectangle is how much? 1 into 1 by 2. Triangle part area half base height. Half
Yes,
into
sir.
base is 1, height is 1 by 2.
Sir, similarly, one question you gave earlier and you told about that A plus B whole squared thing.
अरे वो तो एनर्जी है सिर्फ एरिया है दोनों का फर्क क्या है वहां पे
Okay.
एनर्जी होना है
Yes, sir. There energy and here only area.
सिर्फ एरिया है
Okay, here also if we ask energy, then we have to apply the same thing.
पहले सुनो रेक्टिटी ट्राइटी आप एक्सटी मालूम हो तो इंटीग्रल एक्सटी डीटी बोले तो क्या है डायरेक्ट एरिया अंडर द सिग्नल है ना कहाँ है एनर्जी
हाँ सर सिर्फ एरिया है सर अगर एनर्जी पूछते तो वापस से वो a plus b होल स्क्वायर वाला कॉन्सेप्ट लगाते हैं
यहाँ पे एनर्जी कैसे आता है दोनों अलग फंक्शंस है ना सेम फंक्शंस है एनर्जी पूछ सकते
इस क्वेश्चन में नहीं सर डिफरेंट क्वेश्चन में अगर
if they ask integral signal whole square or spectrum whole square for this type of function a plus b whole square yes you're right
okay sir this was only my doubt
chalo
thank you sir.
yes
Good evening, sir. Sir, in page 27. Sir, here the signal, I mean, can't we use the modulation property here, sir?
Any property you can apply because you can take this spectrum and area under the signal spectrum at origin also same number. But this is easy.
Yes, sir.
If you want to use modulation, two properties you should apply. But with single property only we got the answer, na?
Yes.
You can apply that property also ma. By finding out 12 sync 40 cos 2 pi t spectrum area under the signal spectrum at 0 same number 3 only you will get.
Okay, sir. Sir, and page 20.
20?
Yes, sir. Sir, my connection was bad when you're saying about sin 80 by pi t.
Sin 80 by pi t we want energy. If you want to solve this question from time domain, it is not easy. Integral sin 80 by pi t whole square is not easy. That is the reason we are applying Parseval's theorem. What is Parseval's theorem? Integral mod xt square is this quantity. So right side, it is a rectangle. Na? So range of frequency minus a to a, spectrum amplitude whole square d omega. Answer a by pi.
Yes,
so a place if I substitute pi, I know it is sync pulse or not.
Yes, sir.
What is the energy in the sync pulse means directly 1. Pi by pi becomes 1. This integral sink dt yesterday only we studied.
Yes, sir.
Next.
Yes, sir. That's it.
Enjoy. Yes.
Hello, sir.
Sir.
Sir, 24F can you do?
1 minute. Sir.
Sir, this after integration, like e power minus 2t square. So how how you are doing, like 1 by 8? Can you please explain? Like
अरे क्या रे, x into x बोले तो x square है ना, e power minus 2t into e power minus 2t बोले तो e power minus 4t है ना. e power minus 4t इंटीग्रेशन क्या है? e power minus 4t divided by minus 4. लिमिट सब्स्टिट्यूट करो, यही आता नंबर. इतना आसानी वाला भी पूछे ये देखो.
नहीं actually
maybe you think about complex term. This is a real signal.
yes.
This is a real signal.
Okay.
और क्या है?
Thank you, that's it.
Yes.
Hello.
Sir, बोलो.
Sir, you did that equivalent bandwidth, no sir?
क्या होना
Sir,
है?
how did you take that approximation?
It is not approximation here. Whatever the energy an ideal system is taking, this curvature is practical system. Practical filter will have a curvature or not. Over that bandwidth, whatever the energy that is taken by that system will create this formula. In communication, they are going to derive this equivalent bandwidth. Noise equivalent bandwidth, noise equivalent temperature. There is a derivation in communication subject.
No sir, we have not done, sir. We have done communication, but we have not done. Sir, I wanted you this one, sir. Under root pi by 2 pi, sir. Sir, how you did under root pi by 2 pi?
अरे बच्चा, एरिया अंडर गॉसियन फंक्शन फार्मूला क्या है? माइनस इन्फिनिटी टू इन्फिनिटी e पावर माइनस ax स्क्वायर dx. क्या लिखा हम? रूट पाई बाय है ना.
अंडर रूट पाई
बाय हम जीरो से स्टार्ट कर रहे हैं ना, इसीलिए 1/2 एडजस्ट किया मैं.
ओके सर, ओके.
वही है.
थैंक यू सर.
एक बार प्रिंसिपल ऑफ कम्युनिकेशन सिस्टम टॉबन शिलिंग देखो, उधर रहा था डेरिवेशन. आपको होना है.
ओके सर, ओके.
राइट.
ओके सर, थैंक यू सर.
राइट. Who is next?
Hello, sir.
Yes.
Sir, how to find the inverse system of a signal including exponential under integral?
What is that?
Sir, I want to find inverse system of a signal, sir.
Which
It
signal?
is like
Give me one example.
integral minus infinity to t
Ah.
e power minus t minus tau e power minus of t minus tau
X
into
of
x
tau
of
minus 2
d tau. Yes, sir.
impulse response you
Inverse
compare
system, sir. Inverse system.
It is not inverse system. पहले impulse response solve करो, then we can use this property ht convolved h inverse of t is del t. We discussed inverse system concept na. So if you substitute t tau minus 2 as lambda, you are going to get impulse response like this ma, e power minus t minus 2 u of t minus 2. Okay. So how to find inverse? If you are failing in time, go to Laplace. What is Laplace of this function? Hs into h inverse of s is 1. So h inverse of s becomes 1 by hs na.
Yes.
From that you can solve.
I'll try, sir.
Yes.
Thank you, sir.
Yes.
Hello.
Ramp equation 10 power of 6 1 minus f by 10 power of 4. How it can, sir? Can you explain it, sir?
Ramp expression mx plus c yeah. This height by width concept is there na, negative ramp. That way I have written directly that expression. At f place 0, how much amplitude I should get? 10 power minus 6 we got. If I substitute f place 10 power 4, 1 minus 1 0. There. Mx plus c here, height by width into f plus. Like that we are writing or not?
Thank you, sir.
Find out. Yes.
Sir, last problem, sir.
Which problem? Last problem 28. Yes, sir.
Sir, how did we get sink of f rect of t?
Sink of f rect t है.
Yes, sir.
इधर देखो. From yesterday onwards, 7 hours we studied. Rectity means where it covers. Rectity means where it covers minus half to half, na?
Yes, sir.
The amplitude. How to write the spectrum with a SA function logic? Area 1 SA omega by 2.
Yes, sir.
Same answer in terms of sinc function is sinc omega by pi.
Yes, sir.
Of course, 2 is also there internally. Omega plus 2 pi if you substitute, it is sinc of or not? Tell me beta.
Similarly, yes, sir. Yes, sir. Similarly for triangle function. Sir.
What? Similarly for triangle also, sir. Correct.
Yes. Okay, sir. Thanks.
और कौन है? अरे
Hello, sir.
sir.
Sir, actually, I mistook the slides. 22F. Can you go?
1 minute,
please?
1 minute, 1 minute. 1 minute. First, I am saving the file anyway. They will upload for you. Wait 1 minute. You wait.
Okay, okay.
22.
Yes. Sir, this is that e power minus 2 mod t square. Like it will be like e power minus 2 t square, right?
So positive interval mod t is plus t, na?
Yes.
I have taken 2 times 0 to infinity mod t plus t, na? E power minus 2t whole square bole to?
E power minus 4t square.
4t square. Arey!
Oh, positive side only we are taking.
क्या रे? E power minus 2t multiplied by e power minus 2t x into x है ना? क्या होता है?
Okay. Got it. I thought total square.
हो गया?
Okay. Got it. Thank you.
Hello, sir.
Sir.
Sir, I have a doubt in linearity, sir.
What?
Sir, here given y of n equal to x of n if x of n is greater than or equal to 0. And 0 if x of n is less than 0. Sir, how it is non-linear, sir?
मैं क्लास में बताया ना, सेम प्रॉब्लम बताया, फिर भी पूछ रहे सेम प्रॉब्लम. देखो क्लास में ऐसा बताया, yt equals to xt for xt greater than 0, 0 for xt less than 0. Linearity means what is the immediate thought we need? Output amplitude versus input amplitude graph. It is mentioned output is input only for positive inputs, negative inputs it is not there, which is not a direct straight line curve, non-linear. We want straight line as the relation or not like this?
Yes, sir.
Oh, but it is not there, gone. Same problem class में बताया, देखो एक बार.
Yes, sir.
और क्या है?
That's all, sir. Thank you, sir.
Still they are there. Who are there? No one is visible to me. Yes.
हेलो गुड इवनिंग सर.
गुड इवनिंग माँ.
सर आप बहुत अच्छा पढ़ाते हैं सर. थैंक यू सो मच फॉर टीचिंग अस.
Okay, thank you.
And please try to respond after the class only, like after the syllabus complete हो गया sir.
Your voice is breaking, ma. What you are asking?
Sir, I'm telling like that after finish the syllabus also, if you try to reach out, please respond that time also, sir.
After completion of the syllabus also, if you have any doubts, feel free.
Yeah.
Okay, no problem, ma. Anytime I will discuss, no problem.
Yeah. Thanks a lot, sir.
Right, ma. Thank you.
Sir, for sink square f triangle ఎట్లా వచ్చింది సార్? అది మాత్రం రావట్లేదు.
రాదు నాన్న, ఎందుకు రాదు? ట్రై చేస్తే వస్తుంది మనం. ట్రై చేయకుండా రా అంటే రాదు మన దగ్గరికి.
సార్ అంటే సింక్ ఎఫ్ నుంచి రెక్ట్ రాయాలంటే మనకి అంటే రివర్స్ కండిషన్ ఎట్లా తెలుసు?
కూల్ నీకు ఇప్పుడు కన్వల్యూషన్ లో జస్ట్ మినిట్ ఏ స్లైడో గుర్తులేదు మరి వెనక్కి పోవాలిగా నేను వెయిట్ జస్ట్ మినిట్ నాన్న. ఇది చూడు ఏం కనబడుతుందమ్మా ఇక్కడ ఎస్ఏ స్క్వేర్ ఒమేగా బై 2 రాసామా? దాన్ని ఏం రాయొచ్చు నేను సిక్స్ స్క్వేర్ లో బై 2π రాయాలి. ఒమేగా ప్లేస్ లో 2πf పెట్టినాను ఏమొచ్చింది? ఇక్కడ ఒమేగా ప్లేస్ లో 2πf పెడతాముడు ఏమొస్తుంది? వచ్చిందిగా ట్రై చేయండి, టెన్షన్ పడద్దు నాన్న, అన్ని వస్తాయి. కొద్ది కూల్ గా ట్రై చేయాలి. ఓకే రైట్. Still, I think one more fellow is there. No.
Hello.
Yes, sir.
Good evening, sir.
Good evening, sir.
Sir, page number 7F, sir.
1 minute, sir. Sir.
Sir, here to find Cn, we want to do simply. We will convert this ramp to impulses, no, sir.
Which method? Left side one you are asking or right side one you are asking?
Left side, sir.
What do you want? I want this graph which I can write as a t multiplied by rect t.
No, sir. In a Fourier series to find Cn.
How will find Fourier series, brother? This is Fourier transform. It is a period.
If they given in Fourier series like this.
If they given repetition of the pattern, then you have to calculate Cn only. Yes.
Sir, you said that a simple method, no, sir.
Differentiate you try. ऐसा कर सकते हैं ना right side one.
Left side one, sir.
No. Left side one कैसे होता है? Easy method is differentiation only. I discussed easy method as differentiation for you.
Yes, sir. But doublet also will come, no, sir. Doublet and
doublet. We have a formula na integral xt into del power n of t minus t naught is what? Minus whole power n x power n of tf. That is there na?
Yes, sir. Okay, sir.
Okay.
Yes, sir.
Still they are there. कौन है? Shubhi Jain, she has completed. Okay, I'm leaving.